Dear all, a very good morning to one and all. And my dear colleagues, it's my honor to invite you all, the participants of this event on the last day of our FDP program, Global Trends in Civil Infrastructure Engineering GTCIE 2020.
Hello.
Hello, sir. Good morning, sir.
Hello.
Sir,
Yeah.
good morning, sir. Sir, good morning, sir.
Yeah.
Sir, just we are starting the session. Yes, sir, it is audible, sir.
Hello.
Hello, it is audible, sir.
Yeah. Is my presentation being shared?
Yeah, I think you had just showing the
Title.
normal, sir. Yeah, no. It is not showing the PowerPoint presentation, sir.
Okay. Oh, it is not showing the PowerPoint presentation.
Yes, sir.
It is saying that your screen has been shared, but
just
sir, actually, please. If you share the PPT, then we can see it, sir. If you start the PPT, this is only the folder
in the normal window.
Okay.
In the normal window, it is there, sir.
Okay. In the normal window, it is there. First, I have to press screen sharing. No, new share, and from the new share, I'm moving on to the window. Is the PPT seen now?
I think it is opening, sir. Just 1 minute.
Yeah. It is. If it is ready, then I can go for a slideshow.
Yes, sir. Yes.
You are able to see the PPT?
No, sir. No, sir.
Sir, not. I think only this folder screen is being shared now, sir.
Yes, sir.
You
the
can
folder
just
is
stop
visible.
the sharing for once and again start it, sir.
Okay. Screen sharing has been stopped.
Yes, sir.
Now I'll be sharing the screen.
Yes, sir.
Okay. So I'm moving on to here, then
the PowerPoint open చేసి షేర్ చేయండి.
It is not being displayed.
So good morning.
PowerPoint open చేసి షేర్ చేయనా?
PowerPoint open చేసి షేర్ చేయండి.
First PowerPoint open.
స్క్రీన్ షేర్ ఆఫ్ చేయండి. ఆఫ్ చేసేసి PowerPoint ఓపెన్ చేసి అప్పుడు షేర్ చేయండి. అప్పుడు షేర్ చేయండి.
స్టాప్ షేర్ వచ్చేసింది.
PowerPoint ఓపెన్ చేయండి. ఓపెన్ చేసి అప్పుడు షేర్ చేయండి.
ఓకే. PowerPoint ఓపెన్ అయింది.
ఇప్పుడు స్క్రీన్ షేర్ కొట్టండి.
కనిపిస్తుందా ఇప్పుడు? వచ్చేసిందా?
స్లైడ్ షో ఆన్ చేయండి. స్లైడ్ షో ఆన్ చేసేయండి సరిపోతుంది.
అదే స్క్రీన్ విజిబుల్ ఇప్పుడు? Right. My voice is audible?
Yes, sir.
Yeah, right.
Just 2 minutes, sir. We
Sure.
Time to take 2 minutes, sir.
Sure, definitely, not an issue.
టైటిల్ పెట్టండి మీది. ఎంటర్. ఎస్, మీ పేరు వస్తుంది కదా. Excellent, sir. Wait.
My dear participants, once again, a very good morning to all. It's my honor to welcome you all again on the last day of our event, the Faculty Development Program, Global Trends in Civil and Infrastructural Engineering, GTCIE 2020. Now, in this connection, just I would like to request Mr. B. Haman Sai Kalyan to introduce about our speaker for the today's session.
Thank you, sir. Good morning to one and all. I have this pleasure and honor to introduce our esteemed speaker of this session, Dr. K. Gopikrishna. Dr. K. Gopikrishna Garu is presently working as an assistant professor in NIT Warangal. He has obtained his PhD in 2008 from Earthquake Engineering Department of IIT Roorkee, for his work on wavelet finite elements for structural dynamics problems. He has post-PhD research experience as engineer, GE Aviation Research at John F. Welch Technology Center, Bangalore. He is a recipient of GE Greenbelt Award for proficiency in implementing Six Sigma methodologies in the handled projects. He has worked for BITS Pilani Hyderabad campus before moving to NIT Warangal. His present research interests are performance assessment of RC building under seismic and multiple hazards, reliability analysis of structures. He had several journal publications in the areas of seismic performance assessment of RC buildings, performance assessment of RC buildings under multiple earthquakes, wavelet finite element methods for structural dynamics problems. We, the Civil Department at our Institute of Aeronautical Engineering, IARE, are extremely delighted to have Dr. K. Gopikrishna as one of the speakers in this FDP. We wholeheartedly thank him for his participation in this event and for sharing his valuable knowledge. Thank you, sir. Over to you.
Shall I go ahead now?
Yes, sir.
Yes, yes, sir.
Is the screen open to me?
Yes, yes.
Yes.
Can.
Very good morning to you all. Today, I'll be discussing about seismic fragility analysis of RC buildings. We all know how important it is to understand the seismic fragility in today's context. Because as we have seen in the past, if you could look at the way our codes have been revised, the way things have been done, you could understand the impact of earthquakes on uh, our human uh, habitat. So if you can see most of the urban habitat as of now, we can see that there are a lot of RC buildings which have come up, and there are a lot of RC buildings which are existing right from the beginning in the urban habitat, but the safety of those particular structures is always questionable until or unless they conform to the code of practice at that particular location. We all recognize this. We all know this. So our main this thing is we need to look how to address this particular safety of these particular structures. Now, coming on to fragility analysis, to give an overall view of exactly what the talk is all about, fragility analysis happens to be a probabilistic tool which helps us to describe a failure phenomena with respect to a parameter. So, fragility analysis is a very independent uh, tool which can be used in any discipline or a domain. So, at present in this particular talk, I'll be trying to uh, explain how fragility analysis is being used to describe the behavior of RC buildings. Because we are talking about RC buildings, so we'll be looking about how fragility analysis will be used in RC buildings. How are we going to develop those particular relationships, and how those relationships are useful in describing the behavior of RC building. And we all know that this fragility analysis are only a probabilistic tool, and this is an independent tool. It depends upon the analysis background. Please understand, analysis is what is very important to us when we look at this particular analysis, when we look at this fragility analysis. So coming on to this, if we can look at why we need to go for this particular study, I think everyone recognizes that uh, earthquakes are one of the unavoidable natural hazards. We know they are the natural hazards which we cannot avoid, and they can lead to a disaster. So the only way left to us is how to safeguard ourselves from this particular hazard. So the only way that we can overcome or mitigate this particular hazard is to look at the mitigation steps. Earlier, people were thinking that RC buildings happens to be very safe, so there should not be any issue if an RC frame has been stable and people have been living in an RC building. They thought it to be very safe, but the earthquakes happened in the last 2 decades. The Latour earthquake and all Bhuj earthquake have really exposed the weakness of our RC buildings. That is the reason why there were a lot of revisions in our seismic codal provisions. That itself is a evidence that a lot of research has been focused in this particular direction to safeguard ourselves from the disaster. And our earthquake disaster report also presents to us that the 59% of the area is vulnerable to moderate to severe earthquakes. This is very clearly evidenced in the earthquakes that we have faced. I have given few representative earthquakes just to understand the severity. We have Nepal earthquake, Sikkim, Jabalpur, Chamoli, Latur. In all these earthquakes, lot of damages have been witnessed, in particularly the RC buildings. There are a lot of damages happening to the other side of buildings. As the focus is today on RC buildings, so we could even recognize a lot of damages that has been happening to the RC buildings as well. And it has been very clearly said that more than 90% of these casualties are because of non-conforming structures. This is where we do not have the control. See, an engineer tries to design the building, but he doesn't have a control on enforcement of the seismic provisions at the site location. As long as that enforcement of the codal provisions does not take place, the safety of that particular structure cannot be guaranteed. As that becomes a non-conforming RC building. So whenever we have a non-conforming RC building, those non-conforming RC buildings are becoming the vulnerable building stock as of now. And these, because of the main reason for this non-enforcement is mainly because of incognizance among the stakeholders. I should say it is mainly because of incognizance of the incognizance among the builders, incognizance among the residents about the importance of this seismicity and the seismic forces that needs to be considered in order to be safe in case of an eventuality. They think that we are staying in zone 2, we never experience any earthquake, and why we need to look at this particular aspect. This additionally increases the cost of our particular construction. So why we need to concentrate on this particular direction? So a little bit of additional cost would make their structure safe in case of an eventuality. We have already seen that India has experienced so many devastating earthquakes in the past, and these earthquakes have really caused a lot of casualties, and that is the reason why we are very much focusing on this particular direction in order to create a safe design structure. Okay, the only way that we can minimize this is by ensuring the code compliance for the new constructions, and we need to look at how our existing structures are behaving. When we are able to ascertain the performance of our existing structure, then we can take a decision whether we need to rehabilitate it, or whether we need to retrofit it, or how we need to bring that particular structures back to the functional level according to the code of practice existing on that particular date when we take this particular analysis. The reason here is, when we look at the RC buildings, we generally have different types of RC buildings that are existing in urban habitat. The reason for different types is because of the inherent functional benefits that are being provided by the provisions that are being provided in the RC buildings. Say, for example, if we think of irregularities, we have different types of irregularities that are being introduced. Why I'm saying is irregular, because it is not normal. Say, for example, we have a provision of having an open ground story in most of our apartment complex. This open ground story adds to a functional level of creating a parking space. But if this open ground story has not been properly taken care of while designing, this leads to a disaster during an eventuality. That we all need to understand. So whenever we need to look at this particular framework, so this open ground story structures are very common. So that is one example. Another one is, if we could look at the irregularities which are being given on the height of the structure. Say one story happens to be quite less compared to the other. So these type of vertical irregularities are generally being created. They are created again for some functional benefits like ventilation or some aspects like that. So when they create that, those needs to be properly taken care of. Otherwise, these particular structures pave the way for a disaster. And do you know the casualties if it happens in an urban habitat, because they are very densely populated, and the casualties that happen because of an eventuality like this will be very, very disastrous. So we need to be very careful while looking at designing these particular aspects. That is the reason why we are looking at what are the various analysis approaches, how are we trying to look at the behavior of these particular structures, and how we can project so that we can create awareness among people regarding the severity of this particular aspect, so that an awareness is being created, and then the codal provisions can be clearly incorporated or implemented even at the site level. So that is the reason why this presentation has been framed. So the fragility of the structure, whenever I say fragility, fragility happens to be a conditional probability. Fragility is only a probability density function which displays a conditional probability of a particular failure with respect to a parameter that is describing the failure. Okay, it is only a conditional probability. Now coming on to the RC buildings or any structure, the response quantities for those particular structures can be acceleration, velocity, displacement, spectral acceleration, or spectral displacement. So whenever we try to describe the behavior of that particular structure, or when we try to explain the probability of exceedance of, that is the way we are going to quantify the failure. So when we are trying to explain the probability of failure with respect to certain response quantities, so we are going to get a probability density function. That probability density function is nothing but a conditional probability of exceedance with respect to a particular value. So this particular way we can try to describe how the failure is going to happen with respect to that particular phenomena. Say for example, if we have an RC building, we may have certain properties. Any problem with this thing?
No problem, sir. You can continue.
Yeah, fine. I could hear saying that someone has raised some hand, so I just
No, yeah. Sir, you can continue.
Fine.
Sir, we will take care of those things, sir.
Sure. Now, coming on to the necessity of this analysis. Now, coming on to the fragility functions, we have spoke that fragility functions happens to be the conditional probability functions. So I would say that this fragility analysis is a probabilistic tool, okay, to assess the performance. And what is the outcome of this particular analysis? We get a probability curve quantifying the damage phenomena, because we are trying to describe the failure in terms of damages that are being incurred on an RC building. So it describes the failure in terms of a damage phenomena. So we can visualize this as a post-processing tool during seismic analysis. Please understand, it is a post-processing tool. So this tool is always dependent upon the analysis capability that is being given to it. Otherwise, this tool is not as accurate until or unless the analysis procedures are accurate. And the accuracy always depends upon the type of analysis that is being used. So if you can look here, the fragility curve, something looks similar like this. So we can have, this happens to be a probability density function which has been described in terms of certain parameters. Parameter can be a displacement or a spectral acceleration, okay, whenever we have a parameter like this and we are trying to describe the probability of exceedance of that particular parameter, we will be arriving at functions like this. These are the probability density functions which are generally being used to describe the failure pattern or the damage of a particular structure. So this is how we are going to describe the fragility function. Now, if we could look at the framework of seismic design, we need to understand that the seismic analysis is the background for all the fragility analysis. So when we look at this particular aspect, the first, this particular flowchart enumerates all the steps that is necessary right from seismic analysis to the fragility and then further loss estimation. We can look here. The first and foremost step lies in hazard analysis. That is, whenever we select a particular location for analysis, we need to first ascertain the seismicity of that particular location. The seismicity of that particular location is studied by either using a deterministic seismic hazard analysis or using a probabilistic seismic hazard analysis. When we do that particular analysis, we arrive at certain, we do those hazard analysis with respect to certain intensity measures like peak ground acceleration, peak ground velocity, or spectral acceleration, spectral velocity, like that certain intensity measures will be framed. And we will be doing the response analysis. Next thing that we are going to carry on is we will be doing the response analysis. That means we will be, first here we are characterizing the force. Please understand, we are characterizing the force, and our response spectra which is being present represent the force of this, the force at that particular location. Response spectra with respect to certain soil characteristics represents the force, and when we have that particular force, we can get the response. And when we have the response, then we can, what is the response? Response we can get, response describes the capacity of that particular structure. When the response describes the capacity for that particular force, then we will be looking whether this capacity really meets that particular force. So we call the terminology of this force as a demand. So whenever our capacity meets the demand, then we say we are going to arrive at a very safe structure. When we try to look at the fragility curve that is being drawn for such a structure, we will be arriving that that particular structure happens to be in a limit state where it is safe. So I'll be coming on to the limit state. That is where we are going to define the limit states to describe this particular structure. And then we are going to see how that particular structure is performing in that particular limit state. Whether we need to improve this particular structure, this all happens for existing structures. Okay. So these limit states, we need to look at where this particular structure is right now. Should I need to improve it, or should I need to leave it as it is? So that decision can be taken when we do this particular analysis. Once we do this fragility analysis, we will be able to arrive at that particular decision. Once we arrive at that particular decision, next we are going to go for the next step. This is left to the other stakeholders, how to look at the loss assessment, and then we are going to, whether we need to do any changes for that particular structure, how to get it back to the functional level. If it is not in the functional level, how to get it back to the functional level. Okay, that is where we need to look at that particular case. It depends upon the case-to-case basis according to the buildings that are being examined. So when we, so as we have discussed till now, whenever we look at the RC buildings, we generally look at RC buildings as two categories in terms of analysis: the existing RC buildings and new RC buildings. And the existing RC buildings, the analysis procedure is slightly different because they are already existing. So we need to examine that particular RC structure in order to understand its position and then try to see what needs to be done. And in case of new RC buildings, if we can perform the analysis directly according to the seismicity of the place, and then we can predict the expected damage pattern for that particular structure. Depending upon that, we can arrive at the design forces and then do the analysis. Now, looking at the existing buildings, we all are familiar with our existing buildings. We have several buildings that are available like this. I have taken few photographs from the web just to showcase how the structures are. And we'll have some structures like this, typically representing the open ground story structures. And in these open ground story structures, these ground story columns had to be redesigned according to the forces that are coming onto it. Otherwise, this structure uh, can pave to a disaster. Now, coming on to the structural models, whenever we are designing new RC buildings, we will be looking at different structural models like this. So, different types of structural models can exist. So, I've just shown you a representative example. So, we can have different models like this. These are bare frame models. In addition, we can have infill models. So, like that, we are going to analyze a particular RC structure. But when we try to look at these particular structures, if we calculate the time period of this particular structure, generally we try to group RC buildings based upon their characteristics. We call it as personality traits of an RC building. So we try to group those RC buildings in terms of their time period and their natural frequency. When we look at the time period, see our codal provisions give us the way to calculate the time period. An empirical equation has been given to calculate the time period. If it is a bare frame building, we have a particular formula. If it happens to be an infill frame building, we have this thing. But this particular time period happens to be same for all the structures. But in reality, it is not so. So we generally need to perform the model analysis, try to look at what is the fundamental frequency and what is the time period of the particular structures which are deviating from regular structures. Otherwise, our codal provisions almost matches with that of regular structures. In case of irregularities that is being introduced, we need to specially take care of the time period and the frequency characteristics of those particular structures. Now, whenever we are trying to look at existing RC buildings, there are detailed guidelines that is being given as to how to analyze this particular guidelines in our IS code IS 15988 2013 very clearly specifies various guidelines, and I'll try to explain it in a very brief form. Whenever we have an RC structure, existing RC structure, we generally follow a procedure something like that. We select the structure, go for the site visit where we collect all the drawings, all the structural drawings, and try to collect all the information that is pertaining to that particular. Suppose we take an RC building, we collect all the information pertaining to the RC building, then we plan a site visit for that particular RC building. What we call it as a rapid visual screening procedure, or we can have some visual screening aspects like walk around the building. So we really move around the building, and then we have different approaches like RVS, we have P25, we have like that different approaches in which we try to score that particular structure. So the structure can be scored by visual observation. So we walk around that particular building, and time frame is also being given. Generally, it takes around half an hour or so. So half an hour to 1 hour, that is being specified in some of the literature, that it should not take more than that. So generally, this visual screening of this particular, it is being carried out to really understand what is the position of that particular building, whether that particular building exactly pertains to the drawings that is being specified, or is there any deviations. Next, if then according to the visual screening procedure, if that particular structure satisfies the norms, then there is no issue. Otherwise, we need to take a decision that if there are a lot of damages that are being observed, we need to look for further evaluation. So when we are thinking of further evaluation, we are going for field testing. So we need to go for the field testing and then think of how to analyze that particular structure. And in the field testing, we generally carry out the NDT tests and then try to analyze that particular structure. And all the information that we get here from the field is our structural drawings, our field test, which tries to give us the material characteristics, and then the rebars which are being used, how is the reinforcement being placed. Once we get all these tests, then we can use these inputs to develop an analytical model, and then we can perform the analysis and try to check whether this particular analysis makes sense or not. Otherwise, we need to again cross check our particular details. If we compute the, if once our model is pertaining to the details that we have been collected, then we are going to go for further analysis. We are going to calculate all the seismic attributes that are necessary, like we calculate the base shear, we calculate what is the seismic capacity. Once we understand the capacity, once we ascertain the demand at that particular site location based upon the response spectrum of our code, or if we have the site specific uh, response spectra, then we can analyze with respect to that particular response spectra and try to analyze the performance of this particular structures. So that is where this fragility curves will help to us. Once we ascertain the performance, then we are going to look at whether in which threshold that particular performance point is, and how is the damage probability of that particular structure is. And another way of looking at it is, if we have to look at the internal components, say this fragility curve tries to give us the global performance of that particular structure. If we are trying to look at the local performance of the structural components, we need to look at the plastic hinge pattern of that particular RC structure. When we look at the plastic hinge pattern of that particular structure, we will know that which particular structural components have yielded. Depending upon the structural components that have yielded, we need to calculate the demand capacity ratio of that particular structure and ascertain whether they are meeting the demand or whether they are not meeting the demand. And we need to even confirm this with the site location, whether really that particular structure is in damaged state or how is it getting performed. So that is how we need to calculate the uh, structural performance of the individual components. And here we get the global performance of that particular structure using fragility curve. Now, once we look on to the analysis is the background of this fragility development. So once we look at the analysis, we should look at how are we going to develop the capacity curve. So the capacity curve can be developed either using a nonlinear static analysis, or it can be calculated using a nonlinear dynamic analysis. So most commonly used is a nonlinear static analysis approach because it is easier, and only in case of important structures we need to resort to nonlinear dynamic analysis. And in case of nonlinear static analysis, we will be resorting to idealization of that particular structure into a single degree of freedom system. So when we are idealizing that into a single degree of freedom system, what is happening here is the limitation of the nonlinear static analysis happens to be the fundamental mode of vibration of that particular structure. Whenever we have any multi-storied structure, and if the fundamental mode of vibration is dominant, then nonlinear static analysis happens to be one of the most accurate approach. So there is no need for us to always resort to dynamic analysis for our analysis, results. So we can look at the nonlinear static analysis approach, understand how the structure is being pushed from elastic zone to inelastic zone, incorporating all the material models onto it. So whenever we have the analysis procedure, we generally have analysis, linear analysis and dynamic analysis is where our codal provisions recommend to us. And these analysis procedures do not tell us how to take care of the inelastic behavior of the structure. And the inelastic behavior of the structure is generally being taken care of this nonlinear analysis. So we generally resort to nonlinear static analysis or nonlinear dynamic analysis in order to derive the capacity of that particular structure, to understand the capacity of the structure in the inelastic range. So these analyses are being performed to develop the capacity curve. And our there are several structural softwares available right now which directly performs this analysis and gives us the capacity curve. And most popularly used software is SAP 2000, where we get the capacity curve once we incorporate the response spectrum. Once we incorporate the response spectrum, we get the capacity curve. Capacity curve is nothing but the maximum base shear which that particular structure experiences. So the capacity curve is nothing but a force deflection curve, and the force deflection curve represents the capacity in terms of base shear. Base shear is the maximum dynamic force which a structure attracts. It is the maximum dynamic force. So the base shear differs from structure to structure. So whenever we do this particular analysis, we get a load deflection curve in terms of base shear versus displacement. So that is the maximum force which any structure can experience. So that particular structure can experience a maximum base shear, and that particular base shear is being distributed among different floor levels according to the procedures given in our code. So we distribute according to the different floor levels, and then we try to see the response characteristics. In case of nonlinear static analysis, we try to push this particular forces according to a predefined pattern. So with respect to a predefined pattern, we'll try to either push it and then try to look at how the response quantities varies from elastic range to inelastic range until collapse. So that is how we are going to describe the capacity of that particular structure. And once we define the capacity, so we all know that the demand that is being specified and whenever we try to look at the demand and the capacity, we can arrive at the performance point. So our ATC 40 describes three procedures to look at how to convert this capacity curve and demand curve onto same axis. So we are converting that into ADRS format, that is acceleration, displacement, response spectra. So we are converting our demand, which will be in SA versus T, and then our response, which can be displacement or any other quantity. So we are trying to our response in terms of capacity happens to be our base shear versus spectral displacement. So what we are trying to do is we are trying to bring these two dissimilar quantities onto same platform, onto the same axis, which is acceleration versus displacement quantity. So we are converting this, and this conversion uses an idealization that this behaves as a single degree of freedom system. So the pseudospectral velocity or pseudospectral acceleration that is being given in order to convert these particular quantities are being based upon the idealization that the fundamental mode of vibration is dominant. So considering that particular aspect, the conversions has been given in order to visualize the performance point. So the structures where the fundamental mode of vibration is dominant, this particular analysis happens to be the accurate enough. So if we look at, once we look at the seismic analysis, this is where we are going to draw the capacity curve. And once capacity curve has been obtained, then if it happens to be the new structure, we will have different control points on the capacity curve. Based upon the control points, we will be looking at the fragility curves. This fragility curve is not a new one. This has been there in existence since 1980, where it has been described as a probabilistic relation between failure of a frequency of failure of a component in a nuclear power plant with respect to peak ground acceleration. And when we are looking at the earthquakes, we are trying to look at the failure of an RC structure with respect to an intensity measure. Intensity measure can be the ground parameter, which is a P ground acceleration, or it can be a spectral acceleration. So we are experiencing the failure, or we are describing the failure of an RC building or performance of an RC building with respect to the intensity measures like P ground acceleration or spectral acceleration. Okay, probability of failure with respect to these intensity measures. And fragility curve happens to be a graphical representation which shows the probability of exceeding the different damage states. Now, if we look at the way this particular analysis is, this particular flowchart describes the entire analysis that is necessary for us to look up to the fragility estimation. See, first what we do in terms of an RC building is we select the building, idealize that particular building in terms of single degree of freedom system. Then we take the hazard analysis report, then we calculate the response quantities for that particular hazard, and then we try to describe, we have the limit states, we define the performance limit states, and then we try to describe this particular structure with respect to those limit states. And if I can clearly put it, I can put this entire flow chart into 4 steps. First thing is we have a hazard analysis here. We have hazard analysis and response analysis for that particular hazard. That is the preliminary step. We need to select the structure, understand what is the hazard at that particular place, understand what is the response of that particular structure with respect to hazard. And once we know the response will be in terms of capacity of that particular structure, that is base shear versus displacement. And when we try to look at the demand and the capacity, you can look here, these are the demands and this is the capacity of that particular structure for that particular demand. And when this demand and capacity has been overlaid in ADRS format, we will be arriving at a particular intersection point called as performance point, and we will be looking at where this performance point is with respect to the performance limits that are being defined for the capacity curve. And based upon that performance limits, we will be looking at how this damage or failure of this particular structure can be described with respect to various thresholds, damage thresholds that we have. We generally define qualitatively as slight, moderate, extensive, collapse. So something like that we will be describing in qualitative terms, and these qualitative terms will be quantified with respect to certain values, and then these curves will be trying to describe them in a quantitative form. And if we have to describe this continuous curve in a discrete form for a specific threshold value, say light or moderate, extensive, or anything like that, we will be describing this particular in terms of what is called as damage probability matrices. These are the damage probability matrices. Now, this capacity spectrum method has been described in ETC 40, and this particular procedure describes the capacity with respect to demand, and then the intersection of this we get the performance point as we have seen earlier, and the plot between base shear and roof displacement, that is what we call it as capacity. And in order to arrive at this capacity, we need to describe the hinge behavior when we are performing the nonlinear static analysis as per the FEMA guidelines. Those hinges need to be defined, and accordingly we are going to arrive at the capacity, and we can perform the nonlinear static analysis in order to arrive at the capacity curve of the structure under consideration. And once we get the capacity curve, the things that are important in the capacity curve happens to be the yield displacement and the ultimate displacement. So we need to have a procedure in which we can identify the yield and we need to identify the ultimate. So our ATC 40 describes us procedures as to how to look at the curve in a bilinear form and then arrive at the yield displacement and arrive at the ultimate displacement. So whenever we have a capacity curve defined like this, the capacity curve, we have a yield capacity here, we have an ultimate capacity defined here. So there are certain formulas which try to tell us how to identify this ultimate capacity. This will be the ultimate capacity which is being described in terms of, see here, the capacity has been described in terms of spectral acceleration versus spectral displacement. So for a particular spectral displacement value, we need to calculate whether this particular value corresponds to the spectral displacement and what is the corresponding spectral acceleration for which this particular structure is having an ultimate displacement. This happens to be the yield displacement. Okay, this is how we are going to arrive at the capacity. And our Hasus manual describes us the equations to calculate the yield and ultimate capacity. Once we calculate the yield and ultimate capacity, then we can define the damage threshold values between the yield and ultimate and then try to describe how the behavior of this particular structure is between the yield and ultimate displacements. So suppose if we have a capacity curve in the form of a sawtooth kind of form in which we can very clearly see that the internal or structural components are getting yielded and then again the analysis is being performed. That is why we get this particular form of representation. When we get this particular form of representation, we will be describing the capacity curve like this. We'll be having an yield capacity, we'll be having an ultimate capacity. And what we generally do is we select the yield capacity and we look at the ultimate capacity as whether du or we need to calculate using 2 times of dy into au by ay, whichever is higher. We will be taking the ultimate capacity of this particular structure. So like that, we will be calculating the yield, we will be calculating the ultimate, and then we will be trying to move with the fragility. So as we have discussed earlier, this is what is the capacity curve development. So the capacity curve development depends upon the analysis procedures that are generally being used. So here we have looked up with capacity limitations of the capacity spectrum method is it can be used for regular structures or we need to use certain modified procedures in which we can take care of the irregularities. But if the irregularities are being present, we will not be able to address using capacity will not be able to address using a nonlinear static analysis. So we need to resort for a dynamic analysis. Whenever we are trying to resort for dynamic analysis, then we have something called as incremental dynamic analysis procedure. So we will be utilizing those incremental dynamic analysis procedure in order to arrive at the capacity curve. So from analysis, we are going to get the capacity curve. And from capacity curve, we are going to use our fragility analysis to project how the behavior of this particular structure is. What is the probability of failure of this particular structure for various damage thresholds that are being defined. We generally, these are the steps which are available. We generally have, this happens to be a demand spectra, which is spectral acceleration versus time period. We will be converting this into spectral acceleration versus spectral displacement. And similarly, we will be getting the capacity curve from the nonlinear static analysis, which is a base shear versus roof displacement or something like that. So we will be getting force versus displacement curve. So once we get this particular capacity curve, we'll be converting it into acceleration versus displacement format using our modal participation factor and the mode shapes. We will be converting this this pushover curve or the curve capacity curve obtained from nonlinear static analysis into acceleration versus displacement format based upon the first mode representation. Please understand, it is based upon the first mode. That means only the fundamental mode is being considered here. And we have then we look at the intersection of the demand curve with the capacity curve, we will be arriving at a performance point in case of an existing structure. And we will be looking at what displacement and what spectral acceleration does this particular structure is performing. And we will be looking at where is that particular performance point. We will be defining the threshold levels like this, like immediate occupancy, life safety, collapse prevention. Okay, so we will be looking at in which particular zone this particular performance point is. Is it in immediate occupancy, or is it in life safety, or is it in collapse prevention, or it has reached the collapse? So however, so we have certain limits to quantify this particular capacity curve between yield and the ultimate. Between yield and ultimate, we are going to define this performance levels. So once we analyze an existing structure, we know the performance point, and the performance point of the existing RC building will tell us where it is exactly right now. So this particular performance point give us this thing that whether we need to improve this particular structure, or whether the structure existing is can be continued as it is for the eventualities, for the future eventualities. So this particular performance point will help us to take a decision. So that is the reason why this analysis is important. When we do this analysis, we understand this, and then we try to look at whether we need to improve this particular structure, or how to rehabilitate, whether we need to rehabilitate it or we need to retrofit it. It depends upon the decision that needs to be taken by the stakeholders. And in order to quantify these threshold limits, we have certain limits that is being defined. We have immediate occupancy level, damage control level, life safety level, collapse prevention level. That is, these levels have been defined as far as ATC 40 has given us this particular limits, so that we can quantify between yield and the ultimate displacement. And this, just to try to put more insight into this particular capacity curve, I have put this particular limits here. See, once we perform the analysis, we get a base shear versus roof displacement curve. This is what we call it as a capacity curve. And if we could look this, if we get a performance point somewhere here in the elastic limit, we say that it is an immediate occupancy. Immediate occupancy means we have very minor damages, and we have very minor damages in the form of cracks like this, and no need to bother about this particular structure. This is safe to live in. Next, when we have our performance point lying here, we are in the state of between immediate occupancy to life safety. Okay, so this needs to be repaired to bring it back to the functional level. Here, this particular structure is fully functional with very minor cracks, and this particular structure is also functional, but it needs certain repairs. Okay, and when we come here, this particular structure has been severely damaged. That is why it is in the life safety, it is in the collapse prevention level. So this particular structure has severely damaged, and it is on the verge of collapse. If we do not take care of this particular structure will not be functional. So and this particular structure anyway has collapsed. So there is no need for us to look at this particular structure. Please understand, the collapse doesn't mean that a RC structure has already failed. We are defining the limits and trying to describe the failure with respect to that particular limits. Okay. Now, coming on to another analysis, we have seen till now a nonlinear static analysis to define a capacity curve, and nonlinear static analysis has got certain limitations that only the fundamental mode of vibration is being used. So the another analysis that we can use is our incremental dynamic analysis to overcome the limitations of our nonlinear static analysis. So the incremental dynamic analysis, we popularly call it as IDA, was proposed by Cornell. In this particular analysis, the first and foremost that we need to do is we need to select a set of accelerograms. We need to select a set of accelerograms depending upon certain criteria that pertains to that particular site conditions. So once we select a set of accelerograms, so that they take care of the uncertainties that are present on the site conditions, and these accelerograms, what we do is Suppose we have accelerograms pertaining to that particular location, we can directly select it. Or we have to select accelerograms pertaining to certain earthquakes which have already occurred in the database pertaining which nearly matches to the site location, or we can select according to certain criteria like earthquake magnitude or source to site distance, or is it a near fault or is it a far away fault. So depending upon certain conditions like that, we can select certain accelerograms. So one criteria has to be set, and accordingly we need to select the accelerograms that are pertaining to that particular location. Once we select a set of accelerograms, now in case we assume that I'm doing the analysis in Warangal city, we do not have any accelerograms pertaining to this. What we generally do, we select a set of accelerograms, we look at what is the response spectrum that is being specified by the Indian Standard Code IS 1893, and we try to develop a spectrum compatible accelerogram. So for all the accelerograms that is being selected, we need to generate spectrum compatible accelerograms. Suppose we have selected n accelerograms, we need to generate n spectrum compatible accelerograms. And once we generate a spectrum compatible accelerogram, now we are going to analyze this particular structure with respect to this spectrum compatible accelerogram, so that we get the behavior of that particular structure according to the site location that is being chosen. So we will be subjecting the structural model to the spectrum compatible accelerogram, and we try to scale this particular accelerograms in different levels such that we try to look at the behavior of this particular structure ranging from elastic to plastic to collapse behavior. So we need to look at which scaling or which particular spectral acceleration this particular structure can move from one zone to another, say elastic to plastic or to until collapse state. So how this particular structure is moving. So depending upon the scaling of each accelerogram, we get a capacity curve. So based upon the accelerograms that are being selected, and based upon the scaling those particular accelerograms, we get one particular capacity curve for an accelerogram. And based upon those records that we have taken, we will be looking at the mean capacity curve, which appropriately defines the capacity. And once we take that mean capacity curve, the rest of the procedure is same. That is how we are going to define the capacity with respect to incremental dynamic analysis. In this incremental dynamic, the main idea is we will be describing it with respect to an engineering demand parameter. We call it as engineering demand parameter. It can be a spectral acceleration or a PGA, or spectral acceleration pertaining to the first mode, or SA average. Like this, we have different engineering demand parameters which we generally use to describe the capacity of that particular structure. And once we arrive at the capacity, rest all the procedure is same. Once the arriving at the capacity is what is important to us, whether we are going with nonlinear static analysis or whether we are going with the dynamic analysis for generating the capacity. Once the capacity of that particular structure is being generated, then we are going to go with the analysis. So this is how we generally create a spectrum compatible accelerogram from the various accelegrams that is being selected with respect to the target elastic spectrum specified by the code. Then we are going to generate the capacity curve like this, and we are going to look at different ways of looking at the capacity, whether it is 16th fractile, 50th fractile, or 84th fractile. Like that, we are going to generate the capacity of that particular structure. Once we look at that, this happens to be the capacity curve. Please look at this. This is the capacity curves. So we will be looking at this capacity curve, and once we know the capacity curve, we will be defining the damage thresholds on this and try to look at what is the behavior of this particular, what is the damage probabilities of this particular structure for the damage thresholds that it is likely to be encountered. And how are we going to look at the fragility estimation once the capacity curve has been developed? Jesus has given us the simplest methodology in order to visualize the fragility curve. And this is most widely being used, most widely adopted, and has been accurate enough in order to describe the damage probabilities of that particular structure after generating the capacity curve. And these curves are take into account the variability and uncertainties involved with respect to the parameters, hazard and response parameters. And we will be defining the damage states like this. Once we know, if we can recall, our capacity curve contains the yield and then the ultimate. Once we know the yield and ultimate, we will be defining the different damage thresholds like slight, moderate, extensive, complete. And there are empirical equations which correspond to those damage states. Slight damage states, we can define an empirical equation like this. Moderate damage state. So Jesus has given us this particular empirical equations to define these damage thresholds. And once we know, once we define these damage thresholds for a particular capacity curve of a particular structure which we have obtained from the analysis, then we can draw the fragility curves for these damage threshold values to describe how the probability of failure of that particular structure is. So we can look here. This is how the damage thresholds are. Whichever I have given here in empirical equation form, I am showing it in a graphical representation. This happens to be our bilinear capacity curve. We will be having the different thresholds SD1, SD2, SD3, SD4. Okay. And then once we define that particular damage thresholds, you can very clearly look here. This happens to be the basic equation for drawing the fragility curve. This is a conditional probability function where probability of damage state with respect to a spectral displacement is being defined as a normal probability distribution. This is a log normal curve. So this happens to be the probability density function, which is describing the behavior of that particular structure. Once we know the spectral displacements, once we know the damage thresholds, once we can estimate this particular beta, these are given by the Jesus manual to us. So once we know this, we can utilize this particular equation in order to generate our fragility curve. So we will be having these values which are being specified, and we can draw a curve something like this. We can see here, these are the damage thresholds, SD1, SD2, SD3, SD4, which is being specified by the Jesus manual. So we can generate these depending upon the damage thresholds. And then this is how we are going to describe the behavior of any particular structure. So that is how we generally generate. I'll take you with an example so that things would be more clear. In general, it will look like this. So this happens to be the performance levels. And then these are the, you can see this happens to be the demand, and these are the capacity curves. And this is how we generally take a decision. See here, this capacity curve happens to be a weaker, representing the weaker building, and this represents a stronger building. So depending upon the damage states, this happens to be light, moderate, extensive. So depending upon the damage states, we are going to look at the performance capacity curve and then decide the performance of that particular structure. Now, I have just taken an example from net to just show you what are all the steps we generally carry out. This happens to be an example which is being taken from the literature. It happens to be a 10-story building with the characteristics. So this is how we generate a structural model. And once we generate a structural model with appropriate material models and then the material characteristics of that particular model, we are going to perform a nonlinear analysis so that we can, nonlinear static analysis, so that we can generate the capacity curve. This is how we generate a capacity curve in a structural software. We can use any software like SAP or ETABS or OpenSys or any other software which is available. So it generates this particular capacity curve. This happens to be the capacity curve, and these are the demand curves which are being used for different damping levels. And once we generate this particular capacity curve, we are going to calculate what is the yield and what is the ultimate in this part, what is the yield and what is ultimate in this particular capacity curve. So we will be calculating what is the yield spectral displacement and what is ultimate spectral displacement. Once we calculate the yield and ultimate spectral displacements, we know the threshold values that are being given. The slight threshold value is 0.7 times of yield, moderate is yield, extensive is this, and collapse is nothing but the ultimate. So we know the yield displacement, we know the ultimate displacement, so we can calculate these threshold values. So we will be arriving at the threshold values like this. For a particular capacity curve, we will be arriving at these threshold values. Say slight threshold has been this, moderate threshold is this, extensive threshold is this, collapse is this. Then utilizing these particular threshold values, this is SD1, SD2, SD3, SD4. For all these values, we can generate this particular curve. So look how the behavior of this particular structure in different damage states. So this is how we can draw the particular fragility curve for various damage states. So another example, if we take with the infill wall, earlier we have taken a bare frame. If you look at the infill wall, here we need to calculate even the, we need to model even the infill wall in terms of an axial hinge. The diagonal strut model has been taken to be the accurate enough, and if we could model this as an axial hinge in SAP, we will be arriving at describing the characteristics of this particular diagonal strut. So once we perform the analysis, we will be arriving at this capacity curve. See the capacity of the same structure when the infill has been added. Okay, we have an yield displacement and we have an ultimate displacement here. And once we calculate the yield and ultimate displacement, we have certain norms equations that are being specified to calculate the yield and ultimate as per Hazel's manual. And once we calculate this yield and ultimate, we will be arriving at the damage threshold values as described earlier. We have damage threshold values, we know yield, we know ultimate. Then we calculate what are the damage state and what are the threshold values. Accordingly, we will be describing the fragility curve in this particular form. We will be generating the fragility curve for all these damage threshold values based upon the equation probability density function equation. Okay, we will be generating this particular curve. And to study the impact of the fragility curves, we have modeled a regular building with a mid-rise of 6 stories, high-rise of 12 stories, then a building with a slope of 6 stories. So this happens to be from our published paper on fragility analysis. So one open ground story building complex, and then the model of the building where we try to remove a critical column and try to see how the behavior of this particular structure is. So when we have done this analysis, so these are the various structural models that has been generated for that. This happens to be a high-rise bare frame building. This is with infill. This is an open ground story building. This happens to be the mid-rise buildings with a bare frame and then with respect to infill. And then this happens to be a medium-rise building where a critical column has been removed just to see how this particular structure damage states will be when we try to, because this can happen because of any accident. There is a possibility of the crucial column getting lost because of any accident. So we generally, we can even perform the analysis in that particular circumstances to see how this particular structure would behave in case of such a phenomenon. We generally call it as a progressive, it incurs a progressive collapse mechanism. So we could see how the damage propagation within a particular structure could happen whenever there is an eventuality like this. So the fragility analysis helps us to visualize all these scenarios. These are certain representative scenarios. We can even perform the analysis for any scenario that we encounter and try to look at how the structural behavior is. So here we have shown for the infill wall and the bare frame. What we could very clearly observe here is, see, these are the infill walls and these are the bare frame analysis. sorry, this is an infill wall, and then these are the infill walls and these are the bare frames. And we can very clearly see that the failure probability of the infill wall is very high compared to the bare frame analysis, but the lateral stiffness of that particular structure increases with respect to when the infill has been added because of the interaction of the infill wall with the bare frame. So, but the collapse probability of the infill wall increases when compared to the bare frame. And similarly, when we look at a loss of a critical column that is being specified, we can look at the various ways that is being described. Here, we are comparing it with high-rise frame with an infill, and then medium-rise frame with an infill. Sorry, the high-rise and medium-rise frame where the loss of column has been there with high-rise and medium corresponding high-rise and medium-rise bare frame. So the bare frame analysis has been performed with respect to normal bare frame and bare frame where loss of crucial column has been encountered. So this is how the probability distribution is being explained to describe the behavior. We can very clearly see here that the collapse probability for the loss of crucial columns are very high compared to that of bare frame analysis. So like this, we can perform several types of analysis to try to look at the behavior of that particular structure. So the fragility curves really helps us to visualize this particular behavior. So that is why I could say fragility curves are an impeccable tool to describe the structural performance. So we could very clearly see that uh, the fragility analysis tool has been very much beneficial in describing the performance. Based upon that performance, it will help the decision makers to take a decision based upon the performance of that particular structure. So coming on to the observations that we have seen till now, fragility curves are used to characterize the structural behavior in a probabilistic form, and it appears to be a promising tool to understand the seismic behavior, and this tool will be beneficial to the designer to understand the deficiencies that are to understand the inherent deficiencies of that particular structure, and then to design ways to overcome that. And this fragility analysis constitutes excellent information sources and tools for emergency planning, and it will be useful for protection, prevention, and preparedness in case of an eventuality. That is what we need to do in case of an eventuality which we cannot avoid. So whenever we have an disaster, whenever we have an hazard which we cannot avoid, only thing that we can do is we have to mitigate it. So we need to look at the tools which gives us some information so that we can try to mitigate that particular hazard. So I think this is all from my side. Am I audible?
Yes, sir. Yes, sir. You're audible.
Yeah. Yeah.
If you
Yeah.
permit, we can take the question and answer session, sir.
Sure, definitely.
So all the participants feel free to utilize this opportunity, and either you can post your questions in the chat box, which will be read out to the speaker, or else you can use the raise hand option so that we will unmute you and you can directly speak to the speaker. So we got one question, sir.
Yeah.
How to choose damper properties for retrofitting?
That actually does not fit in the scope, but you have to uh, you have good references which are available on that. I think I'll be able to suggest you the references so that you can appropriately incorporate the properties that is being given. Because uh, yes, damper can also be modified, but damping needs an experimental investigation to verify, because numerically it is very difficult to model the dampers. So until or unless we have experimental investigation, we cannot incorporate those properties into the analytical model to exactly see the behavior of the dampers.
Yes, sir. I hope that answers the question. Uh, Next question, sir. This is from Dr. V. Sairam, VIT Vellore.
Oh.
How will we decide whether to use retrofitting or rehabilitation based on the NDT analysis of a building?
Only with NDT we will not be able to decide. NDT gives us what is the structural position right now. So we will be knowing what are the material properties, and once we know the material properties, we will be able to once we incorporate it in an analytical model, we will be knowing the performance level of that particular structure. So based upon the performance level, we need to take a decision. If that doesn't fall in below collapse prevention, or assume that it has fallen in life safety criteria, or it has fallen in collapse prevention, we need to improve it to life safety criteria. Then we have to take a decision to improve the structure. So now when we need to improve the structure, we need to look at the internal structural components which is contributing to this global performance. That is where our plastic hinge pattern will help to us. Based upon the plastic hinge representation of that particular structure, we will know which components are getting yielded and which components needs improvement. So when we try to improve those components using the retrofitting strategies suggested by, you can refer to CPWD manual for various retrofitting strategies that are being suggested. So adopting those particular strategies, we can try to improve this particular structural performance. And then when you try to again reanalyze this, adopting those strategies, analytically we can understand whether it has improved. Once we are sure that it has improved the performance, then we can implement it in the field. This is how we need to cross check the performance of that particular structure. Only performing an NDT, we cannot say that this particular structure is performing this level or it needs retrofitting or rehabilitation. It only gives us the structural behavior. It only gives us the material properties to us. So next we need to analyze the behavior. Only then we can take a decision.
Yes, sir. We got a continuation for the same question.
Yes, sir.
Knowing that the open story structures are more vulnerable against earthquake, why are still people using this type of buildings?
That's what the answer is there in the question itself. See, open ground story structures are vulnerable, but open ground story structures have got a inherent functionality into it. That functionality is attracting people to use it. So when we cannot avoid anything, we need to see how to make it resistant for a particular structure. That is what we need to do, because we cannot avoid open ground story because we need a parking space. Because now most of the places we have apartment complexes where we have many families residing in a very small space, and in order to have parking space provided to them, we have no other option other than going for open ground story or going for cellar parking. So when we provide such a facility, we need to take care of those ground story columns. That is why there are many research papers which have come on that. They clearly specify the magnification factor that needs to be used for the design forces which are coming on the ground story, so that the ground story columns have to be uh, sufficiently improved or has to be designed for the increased design forces which are coming onto it. Only then we will be able to resist those forces. Otherwise, it is just like our human body. See, if our upper part of the body is grows very much in proportion corresponding which our legs cannot bear, automatically we will fall down. So we need to stiffen our legs in order to bear our upper body. So the same thing is there. We need to appropriately stiffen the ground story columns in order to take care of the weight. So appropriately we need to design it. When we cannot avoid it, we have to design it for the increased forces so that it becomes functional and it remains functional throughout its lifetime.
Yes, sir. One more question, sir. Which method is best, whether time history analysis method or spectrum method?
Could not get a clarity. Can you please repeat it again?
Sir, which method is the best among time history analysis method or spectrum method?
See, our you have to be very clear. See, our Indian Standard Code specifies us the time history analysis. It specifies us the response spectrum analysis, and it gives us the equivalent lateral force approach for analysis. So, depending upon what is the task that is there on hand, suppose we are trying to analyze a particular building for the seismic forces and trying to investigate the inelastic behavior, then we have to go for nonlinear analysis only. So we have to go for nonlinear static analysis coupled with the capacitive spectrum approach. Okay, and in case they are very important structures where we cannot expect any sort of failure, then dynamic analysis is the only alternative. Nonlinear dynamic analysis is the only alternative. So you need to look up on whether you are going with the linear analysis or you are going with the nonlinear analysis, which behavior you are trying to understand. So depending upon that, we need to look at. I suggest that for regular buildings, which are whose time period, whose first mode is dominant, nonlinear static analysis is accurate enough in order to give the structural behavior. Only when we have certain irregularities introduced into it, our higher mode participation will come into picture in the solution process. Then we have a difficulty with the capacitive spectrum. Nonlinear static analysis. So we need to resort to nonlinear dynamic analysis and then try to look at the capacity of that particular structure.
Yes, sir. Please suggest some good textbook for this topic.
We have already a textbook on earthquake resistant design and analysis by Professor Pankaj Agarwal and Professor Manish Srikhande of IIT Roorkee, which is being published by Tata McGrath long back. It is a very good textbook which gives you an overall idea of this. It completely gives you an idea right from hazard analysis to retrofitting approach. In addition, you can look at the CPWD manual, which clearly explains you what are the various ways in which we try to look at the retrofitting approaches. And there are very good textbooks by Professor Elnashar, and these are, but we have very few textbooks in this particular area. I do understand that. But for a first reader, I suggest you to go for earthquake resistant structures by Manish Srikhande and Pankaj Agarwal. I think it's a PHI publication.
Yes, sir. One more question, sir. Yeah. What is the role of base isolation in this?
What does base isolation do? Base isolation tries to protect the structure from the ground acceleration, right? So the isolators are being defined to isolate the ground motion for the respective structure. That is the reason why the isolators are being defined. And again, in order to incorporate this, we need to have an experimental validation. Otherwise, we cannot incorporate those isolators appropriately. This is what is the problem with dampers also. We need to have an experimental model so that those particular values can be incorporated in the analysis to look at the behavior.
Yes, sir. So till now, these are the questions. If there are any more questions, please do it as early as possible.
Sir, I have one doubt.
Tell me, sir.
Sir, why we need to consider the first mode shape for the fundamental frequency to develop the capacity curve? Why we are not going to take other modes?
If you could see the IS code, I have shown one example on the irregularities.
Yes, sir.
Our Indian standard code gives us to calculate the time period, right? The time period is same for all the structures. It doesn't take any irregularities into consideration. And when we come on to this capacity spectrum, what are we trying to do? We are trying to transform the capacity spectrum into an acceleration, displacement, and response spectrum format. When we are converting this, we are assuming it as a single degree of freedom and doing the conversion. That is the reason why it is accurate enough for first mode participation. Okay, the equations that are being developed are developed assuming that it is a single degree of freedom system.
So now we have you have shown the vertical irregularities, right?
Yes, yes.
So if it is horizontal irregularities means then what is there any difference?
Even then the higher mode participation will come, and you need to look at the modal analysis to decide which mode is participating, what is the time period. You cannot blindly take from the IS code, because IS code does not talk about irregular structures. It gives an empirical equation for time period which is accurate enough for regular structures. The irregularities which you try to introduce in the regular structure, you need to do a modal analysis in order to understand what is the time period and what are the frequencies that are participating in the analysis. So you need to go up to 90% modal participation for analysis. So you can cut off your number of modes that are participating looking at the modal participation factor. Once you reach the 90% modal participation factor, you can cut off your analysis at that particular stage. So for that, you can understand how many modes are getting participated in the analysis process. Okay?
Yes, sir. Thank you.
Yes, sir. One more question, sir.
Yeah.
Is there any difference in analysis of structure based on previous code and revised code of IS 1893 2016?
Analysis difference is not there. Actually, what has happened is in designing, our latest code has introduced the strong column and weak beam design concept, and that is not existing in the earlier codal provisions. So this is the latest revision which they have introduced, so that whenever there is an eventuality, only local failure can happen and global failure of that particular structure is avoided. So this is the latest revision which has come in the 2016, in addition to the earlier codal provisions.
Yes, sir. So
one more question.
Yes, yes, sir.
So can we you told that we need to develop the fragility curves for we need to model into single degree of freedom system, right?
Yes.
So if it is a multi-degree of freedom system,
no, fragility. Look here, fragility is an independent tool. Yes, fragility is an independent tool. Only thing we need to see is how to develop the capacity curve. Which analysis procedure we need to use to develop the capacity curve. Okay. Once your capacity curve is accurate enough, your fragility curve is going to describe the probability of failure according to the thresholds that are available. So we need to concentrate on how to develop the capacity curve. Whether we use nonlinear static analysis or we go for dynamic analysis, that is the user choice.
No, that is a single degree of freedom system or multiple degree of freedom system. Can we do both, right? So, we can have a single degree of freedom system. Now, how to make a multiple degree of freedom system into a single degree of freedom system?
That is what is the idealization has been given in our ATC 40. You can look at the procedures that is being given in ATC 40. They have given the empirical equations to convert back.
Okay.
Okay, there are 3 ways in which we can do that. They have given the empirical equations. Accordingly, they have defined this particular capacity.
Okay. Okay. Thank you.
Yes, sir. So
Yeah.
that will be the Q&A session. I think you have answered most of the questions. I mean, whoever has put the question, you have answered each and every one of them, sir. Thank you. So I now request Professor N. Venkatrao, sir, to say a few words.
Sir, is there Hemant?
Sir, Venkatrao, sir, has some technical issues, I think.
Okay.
Venu, sir, you might please.
Yes. Thank you, sir. Thank you, Gopi, sir, to have a very good lecture on fragility curves for RC buildings. And we are very much thankful to be a part of our FDP program as one of the expert lecture. And you have enlightened the what about fragility curves, how to drop the fragility curves for the RC building, especially these are not going to cover even in master's course also. So everybody should know about this. You have enlightened our knowledge about the fragility curves and all. So we are once again thank you for taking your time. Thank you very much, sir.
Yeah, I really thank the management for giving me an opportunity to put a little bit of something what I know to the students, so that now they can research on this particular topic and try to explore more and try to understand what fragility analysis is, how are we going to do that, because this is an evolving tool. This is not a tool which has been at the place. Yeah. So I think I have tried to make justice with my presentation to provide little bit of insight into this particular analysis. So this can be taken as a starting point, and then people can explore from this particular direction.
Yes, sir. Yes, sir. Definitely.
So thank you so
So
much
Hemant, you
for
can take it.
yes, sir.
Yeah.
Yes, sir.
Yeah.
Thank you so much for sharing your valuable knowledge, sir. I hope that was very informative for those who are aspiring to do research and career update, research, earthquake, etc. Earthquake research. So I thank you once again, sir. The the next session will be starting within a few minutes. We have the speaker for our next session too with us right now.
So can I leave this
Yes,
session
sir.
right now?
Yes, sir. Yes, sir. You may,
Yes, sir.
sir.
So you
Fine.
can.
Fine.
So the next session in our faculty development program is by Mr. Sriram Babu, sir. So I request Mr. GNV Saiteja, sir, to please introduce our next speaker.
Yes, thank you, Mr. Kalyan. So, as a faculty, in terms of faculty development program, enhancing our technical knowledge is important, and also to improve our skills, the general skills of teaching or being motivating, to always motivate the students. So all the other things other than knowledge is also important. So as the team of IARE has decided, not only enhancing our knowledge skills, to enhance our general skills, we cordially invite Mr. Sriram Babu Garu, who is also a motivational speaker. Along with that, he is an author, freelance life skills trainer, and he is a consultant. His basic vision is to train 1 million and inspire a billion. I hope every faculty should have such a vision, which will be helping a lot the nation. We have to train a million and we have to inspire a billion. Even in general and in engineering teacher or any other teacher is always in connect with the young generation of the nation. So we always have a motto to inspire them at any cost. Also, his mission is to create a transformational learning experience and inspire the young and younger generations to realize their own potential and succeed in their lives. To speak few more words about him, he worked with teams across the globe and has rich multinational and multicultural and multi-domain experience. He has more than 25 years of experience in life skills training, IT, and civil engineering graduate trainings. He's skilled in life and soft skills, psychometric assessment, organizational development, and leadership project and also project management, to name a few. He has a passion for excellence and truly believes that there is no limit to what one can achieve and brings the same attitude into learning lessons. Also, he has several knowledge bases and expertise in development. So in that particular faculty development aspect, his knowledge base and expertise is, to name a few, like employability and life skills for students, interview skills, new joiner orientation success skills, and leadership management, and etc., to just name a few. So, he's also author of few books, few publications, to just say some. So I hope we are very much proud and happy to have the presence of Mr. Sriram Babu Garu to enhance our skills or maybe to motivate us in whatever possible way in this crisis of COVID, mainly where many of them are like sitting in just homes and psychologically disturbed in many ways. So I hope this motivational speech will be very, very helpful for many of us from your side. So now I request Sriram Babu Garu to take over.
Very good morning, everybody. Just to check, am I audible?
So yes,
Sir, you are, sir.
Thanks. Thanks a lot.
Sir, you are audible.
Very nice. Yeah. Thanks so much for a great introduction. I never thought you would read so much about me. Thank you so much.
Thank you, sir. My name is Sai Teja. Yeah.
Sai Teja, thank you so much.
Yes.
Well, my dear friends, firstly, I congratulate all of you for being part of this FDP. In spite of free time you have chosen to spend your quality time on this. This is certainly an investment for your future. My hearty congratulations to all of you. And thank you all of you for inviting me to be part of this program. It was certainly very encouraging. Before we actually start with the session, I would like all of you to go back into your pasts, to where you studied your bachelor's degree, BTech or BSc, whatever it may be, and think of these two questions. Number one, what kind of a student were you? What kind of students you had in your classroom? Were you all very good ones? That's question number one. Number two, did you like all those teachers who came to you? Or did you like only a few of them? Did you hate anybody? If so, do you have reasons for that? Liking some of them or hating some of them? Just think about this. And now coming to the present. Now we as teachers expect our students to be punctual, disciplined, and do whatever we ask them to do. Do you think you were exactly like that in the past? And as a teacher, are you like a teacher you used to like the most? What kind of a teacher are you now? No, you don't have to answer to anybody. These are the questions you have to answer to yourself. When I went back to my past, I remembered certainly two groups of teachers, rather three. One, highly inspirational. Whenever those people's sessions were there, we used to be there punctually in time, and we used to be waiting for them to come in. And if there's a class canceled, we used to get heavily disappointed. The second group, passive teachers. They just used to explain what was there in the syllabus, and that's it. They used to prepare us for exams. Number three, the deadly group. We never wanted to attend those sessions at all. Just to bring two examples from my life, my BTech experience. I studied BTech in civil engineering between 1987 and 91. Just two teachers from my life. One teacher used to come to the class. Every day he used to dictate notes from a book written by Sri Rangawala. And that's it. No explanation, nothing else. He used to dictate notes and then dictate terms to us. So he was sort of a dictator. The second teacher, the first teacher, I don't want to even name him. The second teacher, Professor K.S.V. Radhakrishna. I remember his full name even now. Koduru Sri Venkata Radhakrishna. Amazing teacher. Whenever he walked in, he used to bring in enthusiasm along with him like Wi-Fi. My goodness, such a passionate teacher. He taught us concrete technology, building materials and construction. I remember having his notes a few years earlier also. He was so engrossed into his teaching. And his teachings were from several books, several sources. We did not have internet by then, but then he used to come with a collection of information from several sources. So inspiring. So when I became a teacher, I had two role models. One, not to be like one. Two, like someone else. I'm sharing this experience just to take you to your past and to bring you to your presents too. Just to tell yourself, what kind of a teacher are you now? And today, it's all about a few principles that I've learned over a period of, say, more than 20 years of my experience. Whatever job I did, I have been teaching. So a few principles, very practical, simple, yet so, I would say, life-altering sometimes. I'd like to share with you. So I'll just take a few seconds to share my presentation with you. Now, do you all see the presentation?
No, sir, not yet.
Now?
Yes, yes.
Yeah. My dear friends, a teacher is called a nation builder. As someone aptly said, if you want to destroy a nation, you don't have to throw nuclear bombs on it. You don't have to wage a war against it. You don't need a corona-like virus. All you have to do is to spoil its education system, and the whole nation cripples like anything.
Sir, I'm sorry to interrupt, sir. I'm sorry, but we can't see your screen, sir. I think there's a glitch in.
Oh, you can't see my screen?
Sir.
Is there, if somebody said,
yeah, it is seen now.
Okay, somebody is able to see that.
So you mean to say the screen sharing, right, sir?
Yes.
We can't see the screen you shared, sir. We can see your video, that's it.
You can see me only.
Yeah.
Yes.
Okay. Is there someone who knows how to help those people who can't see the presentation? Maybe you need to touch a box somewhere so that you can minimize my video, my face, and maximize the presentation.
Sir, actually, we've
It
been
was
doing
not shared, sir.
So please
Come again?
try sharing it again, sir. The screen you have shared, please try it again.
Sure.
I think it is shared now.
Is it? How is it now?
Kalyan?
No, sir. It's not being
Not
shared.
sure.
Sir.
Okay.
Is it because the other person is also a host?
It
No,
doesn't
sir.
work that way, sir. You're a co-host, so the co-host can do it. So,
What do you see
sir,
now?
I just see your video, but that too is stuck, sir. Like your picture in the video is stuck. That is what we can see while you speak.
Yes.
Now college poster is seen actually.
So college poster is our profile picture, sir.
Okay,
When we
okay,
speak,
okay.
that comes. When Sriram Babu sir speaks, we can see his video.
Yeah. Now, okay. Yeah,
What do you see now?
Your phone screen, sir.
yeah, it is.
So this is.
No, can anybody tell me if you see two hands with the title teacher?
Sir, one second, sir. I think this is somebody else's screen.
I think mobile screen we are able to see now.
So what do you see, Vamsi?
I think mobile screen, yeah.
Sir, but
Just
this isn't your mobile screen, sir. That was somebody else's. So
Is it?
I'm sorry, but
happens. They're all new to this technology.
all these people are sharing this. I request all the participants to please be patient. Don't try to change your settings. We are experiencing some technical glitch right now. So until we get back to you, please refrain from doing such things.
Try to share once again, sir.
Now, do you see me only?
Yeah.
We see only you, sir, in the video.
What do you see now? Okay. I think I know what to do. Just a moment. Bear with me.
Yes, sir. Now we can see your mobile screen, sir. Now we can see the presentation.
Wonderful. Wonderful. It's my mistake, I guess.
Yeah.
We don't know, sir, whose it is, but we are happy to see this.
Great.
You may continue, sir. This is fine.
I was talking about this, a teacher being a nation builder. Now, if we want to spoil a country, destroy a country, this is what we can do, destroying the education system. This is what the British have done when they have left our country. If you have heard about Lord Macaulay's system, it is Lord Macaulay who designed our education system. And we, the independent India, has followed that education system for several decades. And only after establishment of NCERT and institutions like CBSE that our system has changed marginally and is still evolving. Why am I talking about this? In spite of having such a system, we as teachers can make a tremendous difference. And that is the reason we are called nation builders. Right? My dear friends, look at these words that we are called with. All the teachers are called with energizing, positive, highly influential words. And are you really matching those words? Are you the one who wants to match those words? We can make efforts. And look at these challenges, limitations that we all perform under. The biggest challenge or limitation we have is a syllabus. We did BTech in 4 years. Nowadays, people are doing the same BTech in 8 semesters. So much syllabus to cover. You are given, 16 weeks of instruction and are loaded with too many topics to cover. But this is not a big challenge as such, but there is another challenge some of the institutions have, the managements. They go in one direction and they ask us to take them in that direction. Students, bigger challenge in the classroom. We have a mix of students. Very importantly, time is a constraint, is a challenge as well. And sometimes family can be challenged or a great source of support. What is more challenging with all these constraints? Many of you have to travel maybe 1 to 2 hours every day. Some of you travel even more than that. In spite of that, do you have time for continuous learning? A teacher without learning continuously cannot make the kind of difference he or she wants to make. How do we operate in spite of these constraints or limitations we have? How can we become somebody good to a great teachers? And what are those concepts? What are those little steps that we can take to become a great teacher? And this forms the crux of today's talk. Now, my dear friends, we'll go through a few concepts, the 5 powerful P's to mastery and success. And then we look at the aspects of personality. How are we born and how are we raised? And what makes us all different? No two are exactly the same. We're all different. So how do we take those differences into consideration when we teach and we behave with our students? And the next one, how do we teach or reach a diverse group? Very intelligent students, a few, average and above average, and some of the completely disinterested students. How do we manage them? How do we reach them with different personalities? And how should we be communicating with our students so that we can encourage them? And then finally, we quickly look at the summary. Now, my dear friends, an American institute has done an extensive research on hundreds of thousands of people all over the world. And they've come out with this interesting statistics. They said only a small fraction of the population are top performers. We're actually talking about people who have influenced masses. It's not just about making money. It's not just about making or creating a big business. It is about influencing millions of people. Obviously, the sages in India and people like Swami Vivekananda, Mahatma Gandhi, not wealthy, but then they have influenced masses all over the world. They come under this category. There are slightly bigger fraction of people that are called good performers. We can say all the CEOs of major corporations who are doing a great job running bigger corporations. The vast majority are average performers. And there are very unfortunately poor performers in this world. Can you imagine what percentage of population are in the top category? To our surprise, it is only 3%. Only about 10% people are good performers. And 60%, the vast majority, are average. Very unfortunately, we have the poor performers as well, 27%. The researchers have gone further into details. They wanted to find out what actually made these top performers top, average as average. And they came out with the habits, their styles, etc. And they've taken their research further deeper down. And they found out one very interesting answer. There's only one answer to this. The top performers, good performers, think and feel differently. So to relate this to our fraternity, the teaching fraternity, I would say the top teachers, highly performing teachers, who not only get the great feedback, but also are loved by their teachers. Just like my teacher, Professor K.S.P. Radhakrishna, whom I love the most. I would probably not forget his name until my last breath. And the way these people think and feel about their profession is different, and that is why their actions are different. So the personality begins, whatever we do begins with a thought or a feeling. And that decides our approach. That is why I say successful teachers think, feel, and do very, very, very differently. The way they think, feel, and they think and feel about themselves, the way they think and feel about their students, their jobs, their responsibilities are different. And that is why they become successful, far more successful than many others. Let us see a concept which I think my teachers have employed. Certainly, Professor K.S.V. Radhakrishna has employed this very much. There are 5 powerful P's to mastery and success. The first of all these is a purpose. What kind of a purpose do you have as a teacher? When you step into the classroom, do you go with a definite purpose? Or do you just want to complete the topic? It makes a difference, my dear friends. It certainly makes a big difference. The teacher, I said, used to come with a definite purpose. And every time he used to achieve it. The second P is passion. This actually divides the great and the ordinary. The more passionate you are, the more energy and enthusiasm you put into that. And without any passion, a profession is like a fashion. If there is passion, my dear friends, the next steps are followed. If there is no passion, we don't do much about our jobs. So what is the next P? When you're passionate, you will always do some sort of planning. Another differentiator of a good teacher and a great teacher. In most of the universities, for a semester, all of you get about 16 weeks of instruction. So let us say you have 5 hours, 5 sessions in each week. That means you get 80 sessions. But this is one number. Every semester, you will probably take a few holidays. There will be some days, declared holidays as holidays by government. And some days taken away by the management. You're probably left with, say, 12 to 13 weeks. How many of us do planning for 12 weeks and then have 1 week as a reserve so that we can do some sort of a revision? I visit a couple of colleges very regularly here, and I see people running to finish their syllabi towards the end of the semester. The first 2 units are dealt with very in great detail, and the remaining 3 units are dealt with in no time. You might have heard of Pareto's principle, 80-20 rule. It says, whenever we undertake a project, we complete 20% of the task in 80% of the time, and then we hurry in the remaining 20% of time to finish 80% of the task. Is that what we do as a teacher too? A great teacher should never be doing it. Another P, which is an even more differentiator for a teacher, preparation. And people say preparation makes the separation. A true differentiator of a great teacher. And whenever you get into the classroom, do you practice? Do you think of what to deliver? Do you form a sequence and do you practice that sequence once or twice so that the flow won't break? I came across this concept, say, for about 10 years ago, or maybe 12 to 15 years ago. But my professors, some of them have used the 5 powerful P's to mastery and success. And that is why their names are remembered for a very long time. And my dear friends, look at this. What differentiates the ordinary and the extraordinary? There are many people try to say the qualities of ordinary and the qualities of extraordinary. I would say that little extra thing is the one that differentiates. Extra powerful purpose they have. The extraordinary passion they have whenever they come into lecture. I mean, whatever they do, actually. That extra planning, so meticulous. And they see as if they see the future, as if it is really happening in front of them. And they deliver exactly according to their plan. And they prepare so much. They go wider and deeper into the subject. They can answer you any question you ask. And they practice it so well. You might have heard this quotation from someone else too. I love this. It is said by Bruce Lee, the famous martial artist. Bruce Lee once said, "I'm not afraid of a fighter who knows 10,000 kicks, but I'm afraid of a fighter who knows one kick but practiced it for 10,000 times." Nothing matches practice. You can deliver your content with flawless flow. So, my dear friends, remember these 5 powerful P's: purpose, passion, planning, preparation, and practice. We can be great too. Now, moving on to the second one. We are all different. We are all born different. We are all raised differently. Some of us are born with a golden spoon. Some of us are born into middle class or lower middle class families. Some of us might have been born into poor families. Now look at this. The way we were born, we were raised, is all different. That is why we are all different. The way we approach academics, all these aspects, academic, cultural, linguistic, economic, social, and motivational, all these aspects are different in all of us. And that is why no two are the same, physically or from a personality point of view. So our personality preferences are different. And more importantly, our learning styles are different. We learn differently. The way you learn is matching you, but need not match someone else. So what influences one's personality? An understanding of personality is very, very important so that we'll be able to accept the way our students are, and then we'll be able to help them. So what actually influences our personality? 2 aspects again. Heredity, the way all those genes are pumped into us through our parents, and the environment that influences us. We are a combination of these two influences. Every person has got some free features through their parents and has developed the personality by growing in a certain environment. Now look at this. You certainly remember, I know, whenever people find brides or grooms for their children, in the old days, they used to look at 7 generations earlier, just to make sure the boy or girl is from a good family. That is one part. You receive certain characteristics through your parents, not from your parents. They come through your parents too, not only from, but also through. The second aspect is environmental influence. The way you have been raised by your parents, the schools you have been to, the teachers you have got exposed to during your early childhood, and then, of course, your buddy gang, your close friends, they have tremendous influence on your thinking and personality. And more importantly, if you don't have enough friends, the books you read also influence you. The other experiences you have in life, the news you read, the TV programs you watch, all these things have influence on us. With that said, this is what makes a person: combination of heredity and environment. So these are the personality attributes. We are a combination of these. So hereditary personality has 4 personality types: feeler, intuitor, thinker, and sensor. I don't want to explain them in detail now because it takes a lot of time. And then environment prepares you either to become dominant, and inducement encouraging, and you have these submission and compliance personality types. We are a combination of these 8 characteristics. Can you believe that? We're not just 1 or 2 of them, we're a combination of all these 8. And some of us become introverts or extroverts depending on how we are born and how we have been raised. It's not only about us. Now I request all of you to think of your students. All your students have also the same influence, same personality influences. And on top of this, people learn differently. How differently? These are 3 major learning types. People learn by seeing or watching. They love to see something in the form of a picture or a demonstration or a movie. Those are visual learners. And there are some people who want to listen and who want to read probably. These are called auditory type learners. And there are some others whose learning, the predominant learning type is kinesthetic. These people want some action happening. There has to be some sort of animation, movement, and they want to do something practically. Right? They want to experience it. So all of us have these 3 learning styles inside of us, but 1 or 2 learning styles are predominant in all of us. Maybe 1 in some cases. For example, I am predominantly an auditory person. I want to learn by reading and then listening to someone else. I don't know, when I look at visuals, of course that helps, but then my preference is auditory. Similarly, I'm sure you know what your preference is. But in the classroom, we don't know their preferences. And it is not possible to know what preferences they have. So we have, in a classroom of 60, people with all these 3 learning styles. How do we face them? So how do we reach or teach a diverse group like that, with different personality types, with different learning types, and some highly motivated, and some of them not at all motivated, ill-motivated rather. Some of them are studying for creating their future, and some of them are studying, coming to the class just because somebody else is paying the fee. How do we do that? I would like to tell you a small story. If you have heard this already, let it be a revision for you. I heard this story from a person called Mr. Ramana Rao, Professor Ramana Rao, when I was traveling from Tirupati to Hyderabad by train. I had a habit, whenever I travel by train, I book the lower berth and then offer it to one of the older people, either older people or pregnants, whoever cannot go to the upper berth. So it happened there. An elderly lady asked for the lower berth. I gladly offered it. And this gentleman, Professor Ramana Rao, was observing all this conversation. He asked me, why did you in the first place book the lower berth and then offer it to someone else? I said to him, that's my habit. That is how I do. He got interested in me. And since he asked me a question, I got interested in him. We got into a conversation. He was a disciple of Ramana Maharshi of Arunachalam. This gentleman, Professor Ramana Rao, was a professor in mechanical engineering. And when I met him, he retired as a principal then, and he was serving as an advisor to government of AP. That's in 2010 or 12. I don't exactly remember. Then during our conversation, he said, when he met Ramana Maharshi in person, apparently Ramana Maharshi asked Professor Ramana Rao this question. Mr. Ramana Rao, what do you teach your students? See, the question was asked by a personality who is beyond this material thing, a spiritual master. You cannot simply say, I teach mechanical engineering. That would be a silly answer. So Professor Ramana Rao took some time. He said he would answer that later and came out of that place. Then he came across this story through someone else. Vanilla ice cream that puzzled General Motors. General Motors in America launched a new car. And several customers bought the new car. Several happy customers, actually. 6 months after launching, they got a phone call from a customer. The customer said, my dear people, I don't know what happens with your car. Whenever I go and buy vanilla ice cream from a store, this car doesn't move. General Motors service executives got puzzled. What has vanilla ice cream has anything to do with the car? They got more interested because some customer is saying it. Customer is God, right? So they sent a young executive to the customer to investigate. The young executive joined this customer. Customer explained the problem. After he bought the car, he went to an ice cream store very close to his house and tried to purchase chocolate ice cream on day one, paid the bill, went home without any issues. The next day, his children asked for vanilla ice cream. So I went to the same store, bought vanilla ice cream, came back to the car, started it. The car did not start. He was surprised, tried a few times, then came out of the car, closed the door, opened the door, waited for some time. He tried a few tricks that we normally do. And then somehow the car started. He went back home happily. After a few days, he bought chocolate ice cream. There was absolutely no problem. He went back home happily. But then the next day, he bought vanilla ice cream, came back to the car did not start. When he explained this issue to the young executive. He wanted to see this happening. The executive went to the same store, acted as if they purchased ice cream, chocolate ice cream first, acted as if they paid the bill, came back to the car started. And they went back in again, acted as if they purchased vanilla ice cream, came back to the car did not start. After several trials, then suddenly the young executive remembered. It is a new feature that has been put into the car. When you simply leave the car there without locking it, see, those days, people don't have a habit of locking. Now we are very careful. If you leave it without locking, you cannot start the car within, say, 60 seconds or 100 seconds of it, 90 seconds of it. And that is a new feature. So this gentleman used to leave it without locking, go into the store, buy the chocolate ice cream, which is, chocolate ice cream is not that famous probably, which is deep into the store. So he used to walk inside the store, take one, and then pay and come back. Car used to start because 90 seconds or 100 seconds would have been over by then. Vanilla ice cream was very close to counter. He used to come back in less than 90 seconds, and the car did not start. So when the executive explained this to the car owner felt very happy about it. And of course, when it is a new feature, everybody loves to have such a feature. Professor Ramana Rao, after explaining this story, asked me, what do you teach your students? Oh, come on. I could not answer that question, but the professor said. The next day he went back to Ramana Maharshi and said, I teach my students how to think like engineers. My dear friends, if that young engineer did not remember that new feature, he wouldn't have solved that problem for the customer. So how do we help our students to think? How do we help them to learn more or much more? I would say by understanding how people learn. There are two ways of learning, active learning and passive learning. You will appreciate it when you see this cone of learning. We learn in 4 different ways. One, we receive in the form of words. The second way, we receive in the form of pictures or movements or movies, visual receiving. The third one is receiving and then participating in a discussion or a talk, something like that. The fourth one is actually doing a laboratory experiment or something on the field. These are part of Edgar Dale's research. Now, my dear friends, as part of verbal receiving, there are 3 activities: reading, hearing, and seeing. As part of visual receiving, there are 4. You watch a movie, you watch a demonstration, exhibit, or watch when somebody else is doing something. We learn from that. The third group, receiving and participating, there are 2 activities, like discussions and giving a talk. When it comes to doing it, actually, physically involving in doing it, giving a dramatic presentation, or simulating a real-life experience. So how do these styles, how do these ways of learning influence? We understand that in a few seconds. When we read something, we remember only 10% of what we have read after 2 weeks. Surprising to know, but then that's what happens. You read something once or even twice. After 2 weeks, that is what we remember. When we listen or hear something in a classroom, we remember a maximum of 20% after 2 weeks, unless we do something in between. When we see something in the form of a picture or a pattern, we remember almost 30%. So we're actually talking about the way brain receives information, how the brain loads information into it and recalls. And look at the visual receiving way, the 4 ways: movies, exhibits, and demonstration, etc. You remember 50%. And this is the reason many of the students remember punch dialogues from a movie much better than a small word from a classroom. And the third group, receiving and participating, where we discuss or give a talk, seminars. If you involve in a discussion or a seminar, you remember almost 70% of what you go through after 2 weeks. And when it is doing it really, you remember 90% of it. And what is happening in the classroom? The first 2 groups are called passive learning methods, and the remaining are called active learning methods. If you look at these activities, from reading to doing it really, the brain's involvement is not much in the first one, verbal receiving, reading, hearing, and seeing. The brain involves heavily in the last one, doing it really or simulating something. So the extent of learning depends on the extent of involvement. Now, this is one thing we as teachers have to remember always. Now, how do we encourage active learning? What do we do in the classroom? Now, look at all these methods of teaching we have. Look at the ones that are in red color. If you see the change in color, those in red color are the ones we commonly use in the classroom. We don't do a demonstration. We don't run experiments in the classrooms. We don't encourage discussions. Brainstorming, forget about it. Very unfortunate, we don't get people to work in groups in the classroom. If you ask them to work in groups outside, that is even more dangerous nowadays. Right? Now, even if we want to experiment with these learning activities, your management may not be happy, because these activities result in a certain noise. Actually, that kind of noise, the result of these activities should be like music, but management hears as noise. So how can we take these methods of teaching into active and passive learning? Let us see. The first one, verbal receiving. Our lecture and note giving are part of that. I would say more than 70% of teachers do only this, lecture and note giving. So we are limiting our students to remember a maximum of 30% after 2 weeks, unless they do something in between. When you do a demonstration or an experiment right in front of them, you're making them learn 50% of it. When you encourage them to discuss, ask them questions, intelligent questions, get them to deliver seminars, ask them to work in groups in the classroom. We'll talk a little more about working in groups later. See, you're encouraging them to remember 70% of information that is delivered. When you actually get them to do something like role plays or simulation or whatever practical work, then we know how seriously people take the practical work. I'm very surprised. My elder daughter has done her BTech in electronics engineering, and the way she has taken practical work, my goodness, that was pathetic. I was heavily disappointed. But then what can we do? That is how it was done in their classroom, their college. Look at these methods of teaching put into the cone of learning. What are we doing so far? What have we been doing so far? Is there a way we can encourage students to learn more? You have an answer here. But we'll also see how to do that just in a few minutes. Now, most of the teachers do these things, teaching to the middle of the class. It's not to match the intelligent student. It is not to match the dull student, but we teach to the middle. When we teach to the middle, The dull student may not be able to understand and appreciate. The intelligent one knows it already, so she or he may not appreciate it too. So we are losing almost 2/3 of the class. So we are following this one-size-fits-all approach, old-fashioned. Then how do we change it? This is not a newer method, actually. This is older method. It came into light in 1960s. Very rarely used by people. But then differentiated instruction is the better way than one-size-fits-all approach. What do we differentiate? We can differentiate the content. We can also differentiate the way it is delivered, the process. So in a class of 60, you teach certain basics of any concept, touch basics of any concepts. The dull student may be able to grasp something and then continue with medium complexity and then go with the more complex concept. So you're actually satisfying the needs of everybody. And the process, you can use a blackboard, you can use a PowerPoint presentation, you can use a video, and if you have time and energy, enthusiasm, you can actually create a model at home. You can take it to the classroom if you have time and energy and enthusiasm. All these things help. You can buy one if you have money. Now, look at this thing. Why should they learn what you're trying to teach? So are we trying to encourage the student that this is essential? The question of the student is, what is in it for me? WIIFM. What is in it for me? How many of us, how many of the teachers are telling them where this concept is going to be useful? Many of us say, this is an important question from an exam point of view. This is how some of my teachers told me, and this is how many teachers even now tell their students. So are we preparing them for exam only? Aren't we preparing them for life? And can't we say this particular concept is used when you lay columns? And this particular thing is used when you are preparing the reinforcement? When I'm talking about civil engineering. And if you're an electronics student, electronics teacher, you can say this concept is in this remote, and how that particular concept works with other concepts. Now, what is happening when you relate the concept with some real instrument or the real life application? People tend to remember the name of the concept at least. And most of the students, for sure, remember a lot more. So relate what you are teaching to the real world applications. And that creates a need for them to focus. You can even go on to say, this question, this particular concept is important from a semester exam point of view. In the last 5 years, this concept appeared in GATE exam and IAS exam. You are creating more need for them to learn. And these concepts works in so many instruments. Can we say that? It does require a little more effort. I know. But then all this information is available on the web. You go on Google, name the concept, look for the question papers of GATE, IAS. It takes some effort. And that extra effort is put by the extraordinary. Can we do that? How do we create different learning experiences for different students? There are 3 aspects here: the way we teach, and the way we ask questions, the kind of questions we ask, and if at all you give assignments, you can create different learning experiences. Now, when you teach, you can design your 45 minutes or 50 minutes in such a way that you satisfy different learning styles, different personalities. When you ask questions, Now, I have a very particular suggestion here. There is only one way most teachers ask. Can you answer this question? You ask a specific person. Either you're giving too much of importance to that person, or you're trying to punish that person by asking a question. We used to be really scared when we used to go to the class without preparation. I would suggest two other styles. Let the question be open to everybody. Anybody answer this question? You know for sure you get answers from only a couple of quarters in the classroom. Now let it happen initially. And then the next style, can people from the first line, for first front benches, answer this question? Ask a really difficult question. Can people from second and third benches answer this question? Ask a moderately difficult question. Can people from last benches answer this question? Ask an easy question. Now, what is happening when you ask easy questions to the last bench, moderate questions to the middle benches, and tougher ones to the front benches? You are differentiating. You are encouraging everybody to participate. You are encouraging people to answer. And when you encourage them to answer, when they answer, they feel satisfied. They feel happy about answering. You can ask closed-ended questions and open-ended questions. Closed-ended questions get only two answers, yes and no. And these are designed for last benches. I mean, I'm not trying to underestimate last bench students. Some of them are very intelligent. But then our experience has been that in the last benches, people are not interested. So you know where those dollars sit. Open-ended questions use the question words what, why, who, when, where, how. Ask these tough questions to the tough people. And ask easier questions. Let the normal students answer those questions. When you give assignments, do you design assignments or do you simply copy them? Now, of course, we all copy them, but then we can tweak them. We can change those assignments so that they produce different outcomes. Now ask them to think and write. You can give a single assignment to the whole class or give multiple assignments. Let us say give 5 questions or 6 questions, ask them to answer any 3. And can we design assignments to encourage all learning styles? I don't know how to do that, because I'm not a technical teacher now. But then I heard it is possible. I heard from teachers that it is possible. It takes time again. But then I'm sure by spending some time, you're encouraging your students, all your students to participate. And there is more differentiation you can do. If we can create groups of students in the classroom, give them an assignment, maybe a few assignments of different complexities, ask them to answer any one of them or any 3 of them. And let them choose easy ones. And some of the top students choose the difficult ones. You're satisfying the learning needs of everybody. And slowly, I'm sure some of those ordinary students try to improve themselves because they are tasting success now by answering easy questions. If possible, if your time permits, I would encourage all the teachers to probably dedicate a few hours, maybe 1 hour a week, by grouping the students in the classroom, ask them to write answers to easy to difficult questions. Let them copy from one another. And slowly, copying from one another to writing their own answers. It takes time, of course. This change happens. It takes a lot of time, of course, but we can try. How do we motivate the students? Before I answer this question, ask you this question. When do you feel motivated? Whenever you feel you have learned something, whenever you feel you have achieved something, you feel motivated. Whenever you feel you solve a challenge, whenever you get appreciated, you feel motivated. Exactly the same thing happens to the students. Whenever they feel they learned something, whenever somebody appreciates them, whenever they taste the success of doing something. So ask them simple questions, let them answer it. Appreciate them. When you appreciate, they're tasting success. They feel motivated. And they want to do whatever you ask them to do, maybe going forward. How do you boost confidence? Same thing. Get them to do something very, very well. Give them easy tasks, simple tasks initially. Let them do it well. Appreciate everybody who has put in effort. It's only appreciation that can bring in change. And of course, whenever you need to, you have to keep the wand with you. Keep the stick with you, of course. So whenever you encourage them to do something very well, whenever you appreciate them, that builds confidence in them, and they're ready, they get ready to take on bigger challenges. Some teachers have a habit of not waiting at all for answers. My suggestion, my dear friends, let us wait for a few seconds. It's worth it. It's worth it. A classroom is not a place where we as teachers have to show what we know. The management has already recognized that we know something that we can do, help the students. That is why they've given us a job. So it is not for us. A question is for the student. Give some clues. Draw the answer from them. And when you draw the answer from them, it is your success, my dear teacher. It is your success first. And then it is, of course, a student's success. And it takes the student a long way in learning. And if they can't answer a tougher question this time, ask them to answer in the next class. Let them come prepared. At least one person comes prepared. You made a difference. So think about these aspects whenever you get into the classroom, before you actually get into the classroom. So what teaching aids do we have to accomplish what we want to do? There are some traditional teaching methods like Blackboard we have. And we have note giving, of course. These PowerPoint presentations, videos, assignments, and projects are seen as modern teaching aids. But if you put your heart and soul into designing these, you can certainly make a big, big difference. Videos need not be created by you initially. You can just download some video from YouTube. Let the credit go to the person who created it. Now, while playing the video, while playing the PowerPoint presentation, using animation, you're encouraging all three types. You're showing text here, you're showing in the form of a picture, you're showing movements, you're showing process flows. You're satisfying all three learning styles by showing PowerPoint presentations and videos. By giving specific tasks to do, you're encouraging, again, predominantly all learning styles. How do we use, not how do we use PowerPoint presentation, the uses of PowerPoint. When you use a PowerPoint presentation, first thing, we satisfy almost all learning styles. By creating process flows, movements, we can also satisfy kinesthetic learning style too. So you're attracting the attention of literally everybody in the classroom. The second, of course, when you present something visually, the brain has the capacity to store those visuals. Brain remembers in vivid details, colors, images. These are easy for the brain. And when you show some video, obviously, so if something is moving, brain is interested in it. Now, colors, we can show real colors when we use PowerPoint presentations. If it is a blackboard, you have to have a bunch of color chalk pieces, and it is not so easy, my dear. And when you design a PowerPoint presentation or slide, you can spend some time, good amount of time, design it beautifully, and put in real colors as that is seen in reality. Animation, another one, not only to satisfy the kinesthetic learning mode, but it is interesting. The brain remembers these movements also easily. The other uses we have are these. When you use a PowerPoint presentation, you're actually saving time. And when you keep movements, animation here and there, you're drawing the attention of people. So let us start using such tools. These are the things we can create ourselves. And the last topic of today, how do we communicate? How do we communicate with our students, with the fellow teachers, with other people in our lives? What impact our communication has on them, on our relationship with them? There are 4 patterns in which we communicate. ACES: advising, criticizing, empathizing, and searching. Advising, criticizing, empathizing, and searching. 4 different communication patterns. We actually predominantly use maybe 1 or 2. Let us learn what these styles are, what these patterns are. When it is advising pattern, we have a habit of giving a piece of advice to everybody, what to do and what not to do. When a student comes to you, we tell them without listening to them, probably we give an advice. Of course, as a teacher, that is our job. But is it good to give an advice every time a person comes? Is there a different way? We will understand when we are done with all these 4 patterns. Now, when we are trying to give a suggestion to the student or any other person, when it is our predominant style, we don't listen fully if we are thinking of a solution. When we don't listen fully, we don't understand their issue. Obviously, the suggestion may not be a good one. Going to the deadly pattern, criticizing pattern. My goodness. People with this style, criticizing style, challenge whatever others say. They find fault with others. And this is predominantly due to a tendency to judge other people. And probably people with this criticizing style think that they know a lot of things, or they know everything too well. The third one, empathizing. Empathy is a quality, leader's quality. The empathy is very different from sympathy. Empathy is thinking from others' point of view, understanding how others feel. And it certainly reflects a great positive attitude and makes communication a two-way process. Now, I would say a big difference between 2 teachers. One teacher, whenever a student comes late, immediately scolds. Don't you know you have to come in time? Don't you know that you don't get attendance if you come late? Kind of statements. Many teachers do that. And there are certain other teachers, they do the same thing very politely. Oh, my dear, is everything okay at home? Yes, sir, everything's okay. Now, look at this. This teacher is also talking about the student being late, but the question is different. And you can simply say, of course, oh, just come in, you're almost 15 minutes late, I won't give you attendance. People will feel happy because you're not scolding them. You may give them attendance or not, but then they'll be happy if you understand from their point of view. And there are some students who come late always purposefully. We can't change that. Sometimes we can't change that. The last pattern is searching. Searching is questioning, probing. So this is like asking for additional information to understand the issue a little better. So when you do that, when you ask more information, you're trying to understand the issue have more information so that you can help the person better. We have to use this combination actually. We have to use the combination of these communication patterns. You have to keep advising and criticizing far from us as far as possible, and invite empathizing and searching into your style closer. So that creates win-win communication with a lot of respect between two people, and it develops a great rapport with others in the team, builds trust, and finally, of course, you create a great understanding. So among these four styles, advising, criticizing, empathizing, and searching, empathizing and searching combination produces win-win combination. And of course, after understanding the issue better, you can initially try to bring the solution, draw the solution from the person, or finally, if that person is unable to bring out the solution, you can give a piece of advice. There's nothing wrong. But start with empathizing and searching. Look at these two groups of teachers. One teacher, red color, tightly controlling teacher, does not encourage people, shouts reasonably. And when there is such a teacher, obviously, students don't like the teacher, and students do not like that subject too. That is the problem. And they start to underperform. And there's another group of teachers, encouraging, empowering, gives responsibilities to students, and students obviously achieve big results. They improve themselves continuously. And it has everything to do with communication patterns. If a teacher is advising and criticizing type, that teacher is snubbing growth. If a teacher is empathizing and searching in nature, empathizes with the students, understands their needs, comes from their point of view, we are there for them. So it has to be from their point of view, not from our point of view. And this teacher creates growth. It's not only for the teacher, it is actually for leaders too. The same principle works for teachers as well as leaders. So what kind of a teacher do you want to be? How do you want to communicate with your students? We're coming to the end of the presentation in a few minutes, my dear friends. This is the first concept we started with. We talked about how top, good, and average and poor performers there. They are differentiated by how they think and feel. And what are these five powerful pieces to mastery and success? Purpose, a definite purpose, an extreme passion, planning, preparation, and practice. Those are the five powerful pieces to mastery and success. And we then talked about the way personality develops, the influence of heredity, and the influence of environment on all of us. And I request all of you to remember that your students have also come from different places with different personalities. Their learning styles are different. So no two are the same. We have to keep this in mind when we interact with them. We can't be the same with everybody. Then we looked at cone of learning, looking at verbal receiving, visual receiving, receiving and participating, and then doing it really, the four groups of learning activities as part of those four groups, and the extent of retention each activity has. We tried mapping the teaching methods to the cone of learning. So obviously there are a few active learning methods and a few passive learning methods. Which ones do you want to use in your class? Now I would say when we use active learning methods, people love the way you teach, and people love to be part of that class because you're involving them, right? And then we discussed a lot about differentiation, differentiating the content, differentiating the process. And we talked about forming groups of students, giving them easy to difficult kind of assignments, asking them easy to difficult kind of questions, creating successes for them, small successes for them, encouraging them to answer. And while doing so, my dear teachers, please never snub them. Please don't say this word. Don't you know even this? Many teachers say this. Instead, even if a student gives you a wrong answer, encourage that person. Just don't tell them that it is wrong. So can you try that again? Can you try to think about it again? Now, when you say that person is not wrong, he wants to answer, he or she wants to answer again. And you say, no, that's wrong answer, sit down. That person won't answer again. So think of it, differentiate in your teaching, differentiate your teaching, differentiate your assignments, differentiate the way you treat people. Yeah. And finally, of course, we talked about the communication patterns: advising, criticizing, empathizing, and searching. And what are the two important patterns that create win-win communication? Empathizing and searching. When we advise too much, when we criticize too much, people don't want to talk to us. That's the problem. And before we conclude, I want to tell you something I have learned recently. This is part of convocation address in the old style Gurukulas. They actually start like this: Satyam Vada, Dharmam Chara, speak the truth, follow Dharma, Swadhyayanma Pramadaha, do not neglect self-study. This is what they say. The Guru instructs the students when they graduate from Gurukula. Now, I have learned this from one of the teachers. I'm actually doing a postgraduate degree now at National Sanskrit University, Tirupati. The degree's name is MAIMT, Master in Ancient Indian Management Techniques. All those learnings can be put into my training sessions. That's my goal. So these three lines, I mean, there are several lines as part of that address. These lines are from Taittiriya Upanishad, part of Sikshavalli. Here, the teacher says very importantly, do not neglect self-study. And teacher also says, teach others too. Now, we as teachers, can we have the luxury of neglecting self-study? No way. We are the ones who have to continue learning as if we are going to live for several hundreds of years. The last day of your job, you will be learning. And that is the kind of profession we are in, nation building. My dear friends, as someone aptly said, separation comes from preparation. It is a choice we people consciously or unconsciously make. And when we said separation, we're not just talking about learning a little more. You have to know the breadth and depth of your subject. Follow the 5 powerful P's to mastery. And I'm sure you'll be separate from many, many others. Look at this wonderful statement about the teacher. A teacher affects eternity. He can never tell where his influence stops. I'm sure as long as I teach, I train people, I'm going to mention the names of Professor K.S.V. Radhakrishna, Professor Sriramam, Professor Kameshwar Rao. 3 teachers who have influenced me the most during my BTech. All 3 of them have different styles. All 3 of them have that passion. They're loaded with passion. And when you teach with that passion, you truly make a difference. Professor Sriramam used to follow this problem-based learning method in 1990 and 91. He used to pick up a big problem and then start explaining all the concepts in relation to that problem. So he used to teach design of each of the elements in civil engineering. And while actually designing it, he used to introduce concepts. So come on, we are relating the learnings to the real life scenario. And this is the last one. The mediocre teacher tells, the ordinary one. The good teacher explains. The superior teacher demonstrates. And the great teacher inspires. Which one do you want to be? Which one are you now? Do you want to change? When you change yourself, remember, you are changing a big society. You are influencing a big society. And a true change can happen through a teacher. Nowadays, parents are leaving their responsibilities. We as teachers should not leave out our responsibilities. If we also leave our students, who else is going to help them? My dear teachers, thank you so much for being part of this FDP. And I hope we have covered these simple yet practically useful concepts in detail. And thank you all for your patience who has stayed back until now. I'll be happy to answer any questions. Now I'll
Yeah, sir. Thank
stop
you.
sharing my screen.
Yes, sir. Yes, sir.
Do you see me now only?
Yes, sir. Yes, sir.
Okay.
Sir, thank you so much, sir. It was like, I'll not say it is informative or something. It's like there is so much takeaway for every teacher or maybe for every individual, because it's like we should make it this as a habitat. Like we should live in some particular way. You should think about others also. Like you should think from some other's perspective. So all these aspects are very important for us in daily life as a teacher, or maybe not also as a teacher. And as you are saying, mainly while we are here as teachers, so it is most important for us to live in the way as you were explaining. I hope many of them are already following these points, and also they can add up to their as you have explained more and more points on how in different aspects we should think about the student, we should think about our duties and everything. We have somebody called Nagaraja Rao. Yes, sir. I'm unmuting you, Nagaraj sir. You can speak. Yeah.
Sir, good morning, sir.
Very good morning, sir. Good afternoon, actually.
Sorry. Good afternoon, sir. I am Nagaraj Rao from Karnool.
Sir.
Sir, can you explain that car ideology, sir? I am not getting that one.
Well, the car thing, the company has launched a new car with a new feature, right?
Right.
Yeah, new car with a new feature. And this young engineer, if
no, I am asking which ice cream is going to be delivered late.
The chocolate ice cream was deep in the store, somewhere near the end of the store.
Okay.
So it used to take more time fetching that chocolate ice cream, bringing it to the car, paying the money, and then coming back to the car. So it used to take more than 90 seconds, whatever. So the car used to start.
Okay.
So vanilla ice cream was very close to the counter. So as soon as you get into the store, you can pick it up and then pay, and then take it out.
Okay. Why I asked means to explain to somebody. I asked that one, sir. Thank you.
Wonderful.
Thank you very much. Thank you very much.
Wonderful. Thank you for asking, sir.
Thank you.
Maybe that is what a teacher should do. Like he should learn and he should take it to his students.
Wonderful.
Yeah. So that is So yeah, Mr. Jagannathan, yeah, you can ask your question now.
It's a very great lecture. I enjoyed your lecture.
Thank you so much.
And actually, after long time of service in industry, I came to teaching. After 30 years of service in industry, I came here because
Wonderful.
I like teaching. And actually, whatever you told, all things I'm facing here.
Great.
Actually, even when we encourage students to ask questions, they are not ready to talk. That is the biggest problem. Even I encourage. I will tell even if you are not asking question, I'll ask question to you. Even then, we are finding very difficulty. I don't know why, because other teachers may be discouraging. That may be the reason, I hope so.
So there can be several reasons. Can I answer or can I say something about it?
Yes, definitely. That only I need.
Okay. Now, there can be several reasons. As I said, our personalities are different. Our knowledge levels are different. Now, just imagine if you join a workshop, face-to-face workshop, how many teachers ask questions in a workshop? Not all teachers do that. And when it comes to a student has n number of issues. At that age, the boys may think, if I ask a question that is a useless question, what do girls think of me? That is a big problem for the boy at that age.
Oh.
Yeah. Another thing, the boy may not be able to ask a question in English, maybe a language issue. Right?
You are right. Actually, the language problem is very high.
Very unfortunate. The school system is not encouraging language learning. They are encouraging people to work on M, P, and C, mathematics, physics, and chemistry, which is mad. So unfortunately, institutions that are teaching technical education also have this extra burden of teaching English language. I don't know how many institutions can afford to hire good quality trainers and get the students trained. But then if you take that burden, we can make a change. So I would say you should keep trying, sir. You should keep trying to encourage them. And it also depends on your own body language when you ask them a question. If you are demanding a question from them, they may not ask you. And if you have a pleasing body language, they might certainly come forward to ask you questions. So I'm done with answering that question.
No, thank you.
There's one more hand showing up. Mr. Venkata Seshamurthy.
Yes, sir. Venkata Seshamurthy, I've unmuted you. You can speak.
Yeah. Venkatesh Murthy garu.
Sir, you can even unmute yourself because it's not happening when I am unmuting you.
Can I?
No, sir. He should do that because there is some technical issue.
No, Venkatesh.
Venkatesh Murthy garu, you can unmute yourself, please.
Hello.
Hi.
Yes.
Hello. Good morning, sir.
Very good morning, sir. Good afternoon.
Oh, the presentation of the today's session was highly marvelous. I am assistant professor in Sanjeevani Rural Education Society's College of Engineering, Kopargam, Maharashtra State.
Sir.
At least 25 to 35% of the steps which you have highlighted today, we following in the classroom.
Great to know.
Nowadays, the students who are joining to the institutes are not so much courageous and bold enough to speak, though we are showing sympathy on them. Even if we used to reason, if it is genuine, we used to allow, give attendance, study well, and ask questions. They are hesitating. What is the reason and how we can overcome these negative thoughts of students?
Sir, I'll answer this in two parts.
Okay, okay.
When I studied my engineering between 1987 and 91, we had exactly the same mix of students in my class.
Yes.
So hardly say 3 or 4 students out of 60 used to ask questions. Maybe 5 to 10 students were answering questions. So we had the language problem then also. We had the courage issues then also.
Yes,
right?
yes.
And now look at this present generation, they are products of that generation.
Yes.
Right? So that is one part. So we were also like that.
Yes.
So second thing, we should expect the modern generation to be much more courageous.
Yes.
But there is lack of confidence for several reasons.
Yes, yes.
One of the biggest reasons I see is that they do not know the language well. They cannot speak either the mother tongue or English fluently.
Yes.
Now, in our education system, we have English medium schools where instruction is given in local language and they write exams in English.
Yes, yes.
So these students, very unfortunately, are unable to master one of these languages. They neither know the mother tongue fully nor know English appropriately.
Yes, yes, yes.
This is one big issue. Right? Second thing, I would say the modern generation has loads of innovative ideas in their brains. They're unable to express those thoughts again due to their inability to communicate.
Yes.
So why not give an opportunity to them to speak in the local language? That is one of the things you can do, and slowly change from local to the actual language of instruction.
Yes.
In your case, if you're in Maharashtra,
Marathi.
Let speak in Marathi first.
Yes.
And then slowly encourage them to speak in English.
Yes, certainly we are doing.
And another thing, whenever somebody asks a question, other students immediately laugh without understanding what is asked.
Oh, yes, yes.
That is also there. We have to discourage that tendency.
We are avoiding, of course.
Yeah, these people, whoever is asking, participating, will be participate more often. But I would say these suggestions to do work to some extent only. We have to keep trying. We have to keep finding new solutions.
Yes, yes. Yeah. We should not become desperated.
Exactly, exactly. Ask them easy questions, sir. Very easy questions.
Yes, yes, yes.
Let them answer. Congratulate them.
Yes.
And tell them that to ask these questions in the next class.
Yes.
Let them come prepared and congratulate them in the next class.
Yes.
Yeah, there are several ways.
Yes. May I ask you may I say one more thing?
Please, sir, please do.
As you said, when I was student in up to 10th standard, we had very good teachers. Example, mathematics have been taught by K.G. Vasudevaya, who was the headmaster of school, and Krishnamurti taught physics. Really, it was very highly good basic foundations they have laid for us to come up.
Great.
And even in undergraduation, we had Prabhakar, Mr. Prabhakar, Venugopal, and others. 2 to 3 names I remember today also. Even in post-graduation, Professor Dr. Jesto just recently has passed away.
Oh.
And Amarnath sir, very good teacher, very smooth voice and very good professionalist. Like that we had in our student life. Now we are trying to mold our students also to have courage and boldness. Though we also had English problem, language problem, but somehow we used to ask the questions. That's why I expect from my students also to answer in Marathi first. Great. When I put the question in Marathi, though I do not know Marathi, I used to put the same question which was asked in English in Marathi. Immediately they will respond, of course. Though they may not be able to have courage to speak in front of their friends, but at least they will understand the question what I had asked them. I am giving them opportunity in regional language first and then switch over to English.
Excellent, sir. You keep encouraging them. I'm
Yes,
sure
sir.
one day
Yes, sir. Yes, sir.
they start to
Yes, sir.
actively participate.
Yes, sir. Thank you very much. Thank you
Thank you
very
so
much.
much. Thank you
And
so
I
much.
also got a good experience from your thoughts and presentation, what you have done today.
I
It
feel
is
blessed.
really excellent and fabulous.
Thank you.
Thank
Thank you
you
so
very
much.
much, sir. And stay home and stay safe, sir.
Okay. Thank you so much.
COVID-19 pandemic disease.
Thank you so much, Venkatesh, sir.
Okay, thank you.
Yeah. Is there anybody else who likes to ask a question?
Yes, is still anybody there? You can ask a question. Sir, if you don't mind, I'll ask one question.
Just go on. Yep.
Yeah, like we actually discussed, like you discussed much about teacher-student bonding. I just want to ask a question. How should be the teacher-teacher bonding in terms of molding the student?
Well, in the same department, I would say you sit together, right? Same department sits together.
Yes.
There is always something one can learn from others. Without having that pride in mind, if people can ask the others to share their experiences, there is a possibility of learning from one another. See, we have to work like a family, work like a team, if possible, like a family. But that depends on everybody's attitudes, right? A teacher-teacher bonding should be like I would say like fingers of a hand. We have to work together like fingers work in a hand. If one is encouraging and other is discouraging, and it's not really improvement, right? So I would say we have to take advantage of the strengths of others in order to learn from them. And that's what I can say about teacher-teacher bonding.
Yes, so thank you so much. The next one,
Someone
Mr.
showing hand.
Ramanjnelu. Yeah.
Hello, good afternoon, sir.
Good afternoon, sir.
Sir, thank you for nice lecture, sir. I have learned many new things today. I'm Ramanjnelu from Hyderabad, the CVR College of Engineering, sir.
Sir,
I have one question. Nowadays, how can we inculcate moral values and ethics in our students? Actually, we are trying many times, but what I observed is it is problem from the beginning, that is in school level also. We are trying to tell them many times. Few people are learning, but few people are not getting, sir. How to achieve this?
Wonderful question. Thank you for asking that. And not an easy one to answer. But I would say one thing all of us should understand. Children learn what they live.
Yes, sir.
There is a book with this title written by, there's a lady called Dorothy Nolte. So children learn a lot of things from their parents and families. If
yes, sir, yes, sir.
If their parents do not have a proper moral system, we cannot probably expect a great moral system among the students. So it actually depends more on the parents first. And then you have to remember, according to psychology, by the time a person completes 6 years of age, the boy or girl is almost 90% of adult in terms of psychology. The body is not ready, but then those beliefs are formed, basic beliefs are formed. And imitating mothers and fathers' actions has started already. Now, they exactly replicate the way mother and father behave with others. If mother yells at father, the girl also yells at father. Now, with such families, if people if students are coming from such families, all we can do is to probably tell them stories and real life experiences through which we can probably introduce the moral values to them. Probably talk about Ratan Tata's examples, N.R. Narayan Murthy's life story. Tell them how their value systems have helped them to establish multi-billion-dollar enterprises, and beyond that, they are valued as good human beings. So we can share real-life experiences in order to influence them. Now, see this, the same student who does not probably get influenced by you likes Dr. APJ Abdul Kalam. I would say every student of India is proud, he feels proud whenever he or she hears the name of Dr. APJ Abdul Kalam. Let us bring some stories from his life. If you simply say you have to be like this, you have to be like that, it is like advising. Nobody is ready to take a free advice. And especially students at the age 17, you start to see them at the age 17 until 21, at 22, 23. My goodness, these people come with loads of feelings, a big, heavy student ego. Why should I learn from you kind of attitude? But then we have to accept all of that. I would say stories and real life experiences are some of the ways we can introduce moral values to them. We probably cannot change anybody. We can only make them think about change. That is why a teacher's job is to help the student to think appropriately. And that's what I can do. Even now, I have introduced a few concepts to you, and my request is to you is to think about them. That's what I can say, sir. Hello?
Yes, sir. Yes, sir. That was actually, I hope his answer is done.
Yeah.
Is there anybody still who wants to ask any question?
Yes, Mr. Balakrishna is showing hand.
Balakrishna, our friend, yeah. Yes, Balakrishna, sir.
Yeah, good afternoon, sir.
Hi, good afternoon, Balakrishna.
Sir, as a faculty, how can we stop a student to bullying his, friends, common friends? Bullying you, to tease or something like that. How can we stop as a faculty to not to do such things? This is not a small thing, but many of the students will be in a depression to do some such abnormal things like suicide or something.
Yeah.
So how can we as a faculty can motivate them not to bullying other students?
See, when you want to talk to a person who involves in this bullying activity, discouraging their friends and you talk to them in private. My suggestion is here: follow the feedback system. Do people know how normally, whenever there is annual appraisal, annual feedback between the manager and the employee, this is the way suggested. You talk 3 to 5 very good characteristics of that person, and then start with the negative. If possible, for every negative you want to say, you tell them 2 or 3 positives. So you find this boy who is bullying others, invite him to your place, the faculty room, whatever. And please do not discuss this issue in front of others. Let you and the other boy be there, boy or girl. Nobody else. So when you're finding a mistake, nobody should be there. But when you're praising, when you want to encourage that person, when you're talking about good things about that person, everybody should be there.
Okay, sir.
Now, when you praise the person initially, hey, I see you as a very intelligent boy, nice with everybody, and especially you behave with the girls very politely. And my dear, I see a lot of potential in you. But one thing I don't understand, why do you bully that boy unreasonably?
Okay.
See, a few positives. Now the student gets surprised. Oh my goodness, this teacher has so much of positive impression on me. I should not lose this impression. Don't you think so?
Yes, sir. Yeah.
It is certainly possible. It is certainly possible. So approach it that way. Highlight their positives, and if possible, highlight their positives, and then take the isolation and then talk about the negatives. Yeah.
Nice to hear you, sir.
Thank you.
It's a great lecture by you, sir. Thank you.
Very nice of you. Thank you. Thank you for saying so. I'm blessed.
Sir, Anand sir, yeah, Anand sir, you can. Anand sir.
Anand sir, you have to unmute on your system also.
He's unmuted actually.
Yes, sir. Sir, anyway, we'll continue, sir.
Yeah.
Sir, thank you again. We are very overwhelmed. I mean, we can't express with words also. Now I request Professor Venkatrao sir to speak few words about the presentation.
Hello.
Sir, yes, sir. You can speak, sir.
Yes, yes. So, good afternoon to all my faculty fraternity. I am very happy and delighted to be a part of this great event. I would like to I would like to take my opportunity to express a great sense of appreciation to the lecture presented by Sriram Babu Garu. It's really inspirable, wonderful lecture. I have no doubt and I have no fear of contradiction to state that all the faculty members who could attend the session are benefited from this lecture. So really, sir, it is my privilege to express my sincere thanks on behalf of the Department of Civil Engineering, Institute of Aeronautical Engineering. Sir, it's really that you have touched every aspect and sphere of student and teacher learning system. Sir, that you have told the types of teachers in the society, like an ordinary teacher, a good teacher, and a great teacher. And you have highlighted the role of the great teacher. So, and you told that the great teacher is always needed to the society. And as far as your presentation is concerned, we could understand that the teacher can make the society, can break the society. Because a teacher will be more powerful than even a nuclear or atom bomb. Because the way that we use this atomic energy, we can use it either for construction or for the destruction. So such a powerful role has been assigned right from the annals of the history to the teacher. Sir, I have no any doubt that really to accept with you, sir, the society has been emerged by the suggestions of the great teachers right from the beginning. So it is known that the role of the Socrates, Plato, Aristotle, and to the Alexander, how they are contributed for the development of the human society. So here, this is the right time to point out that the statement given by the great Alexander the Great, he said once, I am indebted to two people. One is to my father, the other one is to my teacher. The father for which he gave me the birth, the teacher for which he taught me how to live. So that was the prominence and importance given to the teacher. So really, sir, we'll always, actually, we are really thankful to you, the way that you have signified and identified the role of the teacher in constructing the society. And once again, I am proud to say that all the participants of this event were benefited by your valuable lecture. Thank you, sir. Thank you for giving this wonderful opportunity to extend our immense pleasure. Thank you, sir.
Thank you so much.
Thank you, Venkatrao, sir. And a final thank you on behalf of Civil Engineering Department, IARE, Mr. Sriram Garu. We are very much enlightened with your detailed explanation of how a teacher should be towards the nation. Sir.
Let me say a few words.
Sure, sir.
Yeah, this is Vamsi Mohan.
Hi, Vamsi.
Hi, Sriram, sir. Actually, we were friends since 1991. Since 30 years, we are friends. We had very spellbinding and motivational session in the morning. Thank you very much for that. And also thank you very much for having accepted our invitation.
Thank you for inviting me.
Thank you once again. Okay. Hope your support in future. Thank you very much.
Oh, sure. By all means.
Okay. Thank you. Okay, Sai.
Yes, sir. So thank you very much, sir. That's what we can actually say to you.
Yeah. And thanks a lot. Final words, my dear friends.
Yes.
I would say such interactions most of the times produce small changes only. We know it, right? In spite of that, we should keep telling people. We should keep informing people. We should keep enlightening people. We should not stop doing it. We cannot expect 100% results always, especially when it comes to teaching, when it comes to training. One of the chairmen of the institutes I visit, he tells me always, if you can influence 10 to 15% of students, I feel that I'm paying you much less than you deserve. He expects only 15% of the students to be influenced. Right? Guaranteed him, in terms of thinking, everybody's thinking should change when a teacher goes into the classroom. They should not be the same people they were an hour earlier. So it is possible with a lot of preparation. I would say one of the ways you can prepare for such influencing sessions is to have a goal where you want to change. Now, many teachers simply come to the college, they go back home, they have lots of responsibilities at home. And very unfortunately, many teachers sit in front of idiot box. Idiot box is television. Such a waste of time. My suggestion to you, my dear friends, spend about 1 to 1.5 hours learning every day. Every one of us can become a great teacher. Every one of us. There's absolutely no doubt. Today, we may not be skilled at the same level, but today, all of us have equal opportunity to learn. All of us have same opportunity to learn. I would suggest that you invest on a laptop, you invest on a couple of books, you probably read a couple of self-help, self-improvement books that help you how to change your thinking. Right? When you do so, you change, and whatever small change that happens in you produces a big change in the classroom. I'm certain every one of us has that potential provided we think that we can do. And thank you very much again for bringing me on this platform. And today, I feel like I have lived this day very well. Thank you so much. Have a good day.
Thank you. Thank you. Thank you, sir.
Thank you. Thank you so much, sir. And
Okay,
yes, sir, you can leave.
How can I find the recording of this video if necessary?
Sir, we will share with you, sir. The link, it is already recording. I mean, it is live on YouTube. So the same link will be shared with you, the recording.
Okay, thank you so much.
Thank you. Thank you so much, sir. Small announcement for the participants. We have one more session, that is the last session for this FDP, starting at 2:30 p.m. So all the details and the certificate feedback forms, etc., will be shared in that session. So thank you, everyone. Have nice lunch and join again at 2:30 with us. Thank you, sir.
Thank you, Sriram.
Thank you, Amsi. I'm leaving the meeting. Talk to you later.
Thank you. Thank you. Once more.
Then I'm ending the meeting.
Okay, sorry.
Yes, you can.